welcome back, guys, to part two of day two of the AR convention. And if you're wondering, yes, we are definitely on the right stream if you're looking for part two at the moment. So don't forget, we've got the virtual lobby. It's going in the background. We'll be throwing some links up to that in the chat very shortly. Also, while you're on the link there for YouTube, don't forget to subscribe and hit the bell icon so you're always notified of what the NMRAx team is doing in the future. But I'm not sure about everyone else out there. I've been having a few withdrawals this weekend doing this convention, and I've lacked one of my best mates' intros. So without further ado, I'm going to actually hand it over to Speed to introduce his own clinic, and we can go from there. Speed.
Well, imagine that you have to come on the show and introduce yourself. So I'm Speed at the bottom of the helix, and today's show is shared with me and David McMorran, who lives in Melbourne, Australia. He first dabbled in electronics at the age of 10, connecting a light globe to a battery. Way to go. Soon after that, he was given an electronics set and could put the parts together, but didn't understand any of it. He claims 40 years later, his son gave him an Arduino, and he didn't understand that either. And as you'll see shortly, his understanding of things has improved quite a bit. So please welcome me and David McMorran. And that's the cue for us to start. So give me one second.
If you're wondering why I've got all this on, it's because I've lost power here the last 3 days, so I'm sitting in the cold, and I need all the warmth I can get.
David, can you hear me? You promised some technical difficulties, right? Well, thank you. Okay, so share button.
Just so everyone knows that this is a live event and nothing ever really goes to plan when it's live, but I see he's now working his mouse well, so Speed, back over to you.
Okay, so we would like to tell you about MQ trains, an inexpensive layout control with Wi-Fi and the now infamous MQTT, famous MQTT. So what we're going to discuss today is what it is, how did it come about, the inexpensive components available, a quick recap of MQTT itself, and then how can you use MQ trains with JMRI, and how can you use it without JMRI. So what is MQ trains? First of all, it's just a bunch of firmware, and it's based on a microprocessor made by Espresso called the ESP8266, a little chip. We all have one in our back pockets here, even Brad, he might deny it. And we decided to write all this code for the ESP01 and the ESP01S simply because it has a 8-pin fixed footprint, which means that we can make PC boards for it and plug these chips on it. You get various other ESP8266 devices, Node MCUs and whatever they call them, made by different companies, but they all come in different footprints, and it's hard to make a board that you can plug something into if the footprint changes in 6 weeks. So it doesn't support the ESP32s yet, but that is the future. So we will head that direction once those parts become available at the same low price. I call these things nodes, and they get the instructions to do things and to tell you things from MQTT all over Wi-Fi. So less wires. These things can drive servos. They can be used to drive solenoid turnout motors, control any kind of outputs and lights. They can also monitor your sensors. Signal control is in development. The binary files are all free to download, and eventually, somewhere shortly after Christmas, it will become open source as well, so you can also see the code and maybe contribute to it. Okay, so here's an example of a board I made. The little blue one in the middle, and the parts on the sides. On the left side is the ESP01. and on the right side is a 16-channel servo driver. And all you need is to plug that 5-volt power supply in at the top, and now you can control, in my case, 220 servos spread over about 30 of these boards in the train room. Why did we do this? There are many inexpensive electronic components available today, and you can just go online, either eBay or Alibaba or even Amazon. I've even seen some of these for sale on Walmart now, Walmart.com, and you can pick and choose and build yourself a big layout. Finding out which ones to get is also simple, not too hard, but how you put them together makes it a little tougher. And when you need to program them, that's not for everybody. As we've seen in the Arduino world, not everybody who attends a clinic is there to write code. They mostly want to just download the code and make it work. So the big objective of MQTrains is to make this technology available to more people by doing the programming for you and to show you how to use them. So the big thing is less wires, less time, and less cost. I also have a 3-foot rule. When I need to fix something, then when you're standing in front of it, it should be less than 3 feet to the left or less than 3 feet to the right to find the problem. So who are these 3 amigos or amigos? In no particular order, it's me, representing the Helix and beyond. Joel Davison lives in Austin. He represents the rest of Texas. And then David McMahon gets the whole Southern Hemisphere, or maybe just all of Down Under. The history is all listed out here. It basically started in 2016. The LSR convention was in Arlington in June. I met Joel during a Miles Hale 3D printing clinic, and I promised Joel one of those Space Navigator 3D mice. And poor Joe had to wait 12 months to get it. Now, I've always been giving clinics on Arduino and wrote articles in our Market Lab for it. And I was working on this one-wire signals from JMRI. So you use the pixels, and JMRI has a mask to change the aspect from clear to stop, and then the pixels do the dance. So when ESPs became really inexpensive, I said, let's go of all the cables, and let's go Wi-Fi. So me and a buddy Chris started working on getting MQTT working with JMRI, and shortly after there was a Python script called MQTT Signal Mask Changer, which is hosted somewhere on blog.rrarduino.com, which you can already set signal mask aspects from virtual masks. So about 2 years later, I met David, and he's going to interrupt me here because the story is how I remember it. He asked about 3D printed signals that can hold new pixels, and what piqued my interest was he said N scale. So the
yeah, but what I was actually asking about was RS485, and you gave me all the answers on that, but that was all complicated. So then you told me about MQTT, so I thought that makes a lot more sense.
So we stayed in touch. You know, shows you N scale is still alive, and became fairly good friends. So in April of 2019, the TX number decided to host an operating session during the November DFW interchange, our 3-year rotation with Tulsa and Houston. So I needed 220 turnouts in less than 6 months. So MQTT and JavaScript came to the rescue. Me and David also worked on a rogue JMRI version. We called it 4.17.3-ish with MQTT sensors, but we please encourage you to download 4.22 or later, because that now supports sensors and turnouts and I believe lights. So at the 2020 LSR Houston convention, Joe asked about the Arduino one-wire signals that I showed at breakfast, and he needed a WS2812B part number, so that within 3 months, he built a little board, and you can see that when we go live on screen, little Penzi signal behind my back here that's changing aspects. So in April of just last year, we created the GitHub account. David joined a month later, And we had 3 guys in 2 time zones writing code, all from a single .ino sketch in C to a multi-file C++ with objects, reusable parts across, where we created web servers to take all the configurations, or a web server of HTML pages to configure anything, instead of me compiling my SSID and my password in. So what we had in the past was just define these strings, and then you had to recompile them, upload them, power cycle, and then you had a hope that it would be working. Where now we have a tiny little web page, a web server that you go to, and if you click on Quick Start, you can configure almost all the same things, plus a lot more. And when you're done, you say save and reboot. Okay, so a little bit about the things we did since then and the things that didn't work. So every constant value changed into something that could be configured by HTML. We used to use EEPROMs. That moved over to the SPIFs file system, and now we're using the little file system, all technical terms, for just some cool things. It means I can upload an HTML file to it, and the web page is ready. No need to recompile. All the configurations are saved in a JSON file format, so you can download your configuration and you can upload your configuration in one file, so easy to save a backup of all your settings. Things that's present that we haven't documented yet is the over-the-air updates. We can already upload a new version across the Wi-Fi to a node, and it will reboot and run the new version. And then there's also a serial interface, which was pretty much all Joel's work, because he, as I claim, likes to have these FPGAs and CPLDs talk to these systems through serial cables. The things that didn't work was like MDNS, Bonjour, DNS, how an iPhone does it different than an Android for when you join the local device's access point. We said, well, maybe we just cut all that code out and let you type in 2.2.2.1 and go to the browser, go to the server hosted by the node. And then we had some hardware trouble with H-bridge drivers to move solenoid motors, but I think we might be close to a solution to that one. So, okay, what about the future? We are done with the I/O board. That code should come out in the next week or 2. We just have to test a few things. Then we need to do the configuration of the signals, like these signals that's behind my back is already up and running. We have 2-headed mast, 3-head masts, we have single-headed masts, we have the PENZ signals that you can also do the B&O signals. But there's no easy way to configure it yet. Then I am dreaming of a MQTrains plant board. Not sure I'm going to get a Q into plant, maybe clant, or the Planck constant, something like that, where if you're on a modular layout, then you have the section as shown in the picture below, part 1, which has a turnout, a mainline and a siding, all the signals that go with it and all the sensors. And with that, we can then have one node per module or one node per plant to reduce the wires even less, so that you don't have to have the signal wires run all the way across your layout to get to those 200 masts that you want to control. The logic QS is so that you can put some logics in there. If this block is occupied and that turnout is thrown, then please make this signal mask approach. So we're thinking about taking JMRI's logics with an X and just find a way to export that so we can have MQTT brains in some of the nodes. We're also working on touch sensors. So you touch your switch stand and the turnout moves over, or you touch the fascia and you don't even have a button there to make it a turnout move. PC board for stall motors, ESP now if you don't have Wi-Fi. We want to move to platform.io instead of the Arduino IDE. That way we get main.cpp back, because everybody believes you're writing Arduino code, but you're actually writing C or C++ code. And then the platform.io will also give us better and easier debugging. And then please, David, clean up that code so we can go open source.
Not a problem.
You're up.
Okay, we were talking a little while ago about inexpensive parts. So this is just a little talk about what sort of parts we mean. Speed has already mentioned the ESP01 or the 01S, which is that little thing in the top left corner. I wish I had one I could show you here at the moment, but they really are the size of a fingernail, so they're not very big at all. A thumbnail, sorry, thumbnail. So that's the brains. Next to that is a MCP 23017, technical jargon for a name. And that's just to provide some extra I/O pins for you because the ESP itself doesn't have very many pins. The item on the right at the top there is just a buck converter. Because we need 3.3 volts for all of these things, and you're quite likely to have a power supply that's a higher voltage. So your buck converter is to drop that voltage down. The PCA board that Speed's mentioned before, that's on the left there. You can plug in 16 servo motors into each one of those. In theory, you can have, I think it's 126 of those. You can do 1,000 servo motors technically, but that's a bit much for most layouts, so we don't drive that many. And the servo motors. So there's the prices of those. Not very much, as you can see. So if you have 16 servo motors attached to that, that's about $1.50 each. ESPs, I bought 10 of them for $20, Australian dollars, that is, from AliExpress in China. $20 including postage. So that's how expensive they are, not much at all. So it works out about $2 per turnout when you put those together. So they're the items in red is what you would use for driving servo motors. The MCP board is where you're driving I/O pins for other things, perhaps like sensors is the most common one. Okay.
Okay, I'm going to interrupt here and do the slide about the Wi-Fi. Most railroads, according to us, should use their own Wi-Fi routers so that you don't have all these crazy people coming to run trains on your railroad that logs into your home network, and then suddenly they start printing switch lists and things on your wife's printer. So please get your own router. All you need is a 802.11b, G, or N router. That's the ESP8266 requirement. When we move into the ESP32 and beyond world, then they might allow these new Wi-Fi 5 or Wi-Fi 6 routers to help. We have tested 22 nodes, ESPs, with both this blue and white router on the right. It's a Linksys. I guess the company's name has changed now, but WRT54G was a very popular model in 2002, and a DIR655, which is made by Netgear. Now, I don't think you can buy these new anymore, but if you want to buy a Linksys N600, my Amazon showed me $30, and then you have a really good 802.11n router from Linksys. So I guess Linksys is still alive. If you do want to go technical, it's not only about the number of devices that you can connect to a router. It also has to do with how the number of open connections. Here at the TX NumUp, we run 35 nodes with 12 tablets and 3 computers, as well as 4 ESP32 cameras. So we invested in a little bit more expensive Ubiquiti Unify AC Pro router. So David will tell us how to set this all up after you install the code on a board.
Yeah, just before I get to that, we'll talk about you only need 3.3 volts. I tell you, I wish I had 3.3 volts at the moment. My household at the moment consists of, my presentation is with my phone and my power bank, and that's it. That's all it's got in my house in the way of electrons at the moment. Okay, so how do we set these things up? We've released the code so far for the servo boards as a binary. So all we have to do is download that binary file, and there's a little uploader program that you download as well. They're all on the MQTrains.com website. So then you just upload that binary file, plug it into your power supply, and it's up and running. Now, when it comes up, it will have its own network running. The name is shown there, MQTrains-0001, and the secret password, which I'm not going to say because that's a secret. And then once you've connected to the network, it's put in the browser address as speed said 2.2.1. And then you get that main menu that comes up from the web server that's on the ESP01 device. And if we move on to the next pic, when you go into that quick start option, these are the details that you would typically want to set up for each person's configuration. You're likely to have several of these boards, so we give them each a unique number, a 4-digit number. You can have whatever coding system you want for those numbers. Don't leave them all to be the same one because you'll finish up. Don't leave the default because you'll finish up with 2 the same and things will get confusing and you'll get not the right things happening. So you need the details to be able to connect to the MQTT server, and we'll talk a bit more about the MQTT server later on. And there's other details there you want for topics and I can't even see with my phone what's underneath there.
SSID and Wi-Fi
and then
key.
The Wi-Fi key, that's what's missing. Yeah, it's blocked out on my screen. These damn telephones. Okay, yeah. So you need your Wi-Fi connection. So that would be the Wi-Fi that Speed has just told you which one to buy. Yeah, it's not good to be trying to run your trains while the kids are watching Netflix on the home network. So good to have your own. Okay.
So if you have a OLED LCD or a serial port connected, or you're monitoring your MQTT server, then you will see the IP address of the module that just joined your own network. Otherwise, you have to log into your router and look in the DHCP table because you would like to go to the device one more time to configure all the things that are connected to it. And that includes servos, how far they move to close and how far they move to thrown. So when you get the new IP address, you no need to write it down because it will change over time as the DHCP table will reassign it, but you will hardly ever need to use it again because you're just using it for setup. David, you're up.
Okay, now MQTT, you've heard us talk about that. I've done a couple of presentations before about that, but we'll just do a recap in case you've forgotten or some people might be new to this. What is MQTT? It is just another internet protocol. Most people use HTTP every day. They may not know what it is. They may not know they're using it, but that's just a protocol that's driving your browser on every time you're searching the web. So that's one of the protocols. FTP is one that people often use for file transfers. Your email server is using internet protocols. So MQTT is just one other in that space. It's just sending messages, and we'll get to those messages. Here we go. So you have an MQTT server. So that's the messenger. And these other devices are called the clients that connect to the server, and they send and receive messages. Sending is, in MQTT terms, is called publishing. So that's when a client such as JMRI wants to send a message to the server. It publishes that message. And other devices such as MQTrains devices will be subscribing to the appropriate topic so that they see that message and then they can do whatever that message is asking them to do. And messages can go the other way. So any client can send or receive, can publish or subscribe, depending on what its function is for. Next. And yeah, sometimes some people like to get a bit more sophisticated. So you can actually bridge your MQTT server into the cloud and get a bit more adventurous and have another JMRI client hanging off that. And Speed likes to have his remote dispatcher a long way away, as far away from you as he possibly can, I think. so he doesn't interfere with the serious running of the trains. So you can do all sorts of things like that. Messages. We talked about what are these messages like? They're not binary. They're not got a whole lot of numbers that mean nothing. It's just plain English. The example there is a topic. Is the topic will be for a turnout. The topic will be for each specific turnout. So each turnout is identified by a topic. There's a couple of components. Is how you define them in JMRI. I'll come back to that in a little while. And then there's a payload, as it's called, is what is it that you want that turnout to do? So you'll be saying closed or thrown to throw or close the turnout. So the MQ trains devices will be subscribing to a topic with the wildcards because they usually have more than one turnout on them. So they get a wildcard to get all of those, and then it can respond to those messages. Instructions. Okay. So let's have a closer look at MQ trains with JMRI. Yes, I've done a couple of topics about discussions about those before, and you'll find them on YouTube if you want to. There's the dates of them. Google will help you find those. Okay. So I won't go through all the details, but we'll just move on. This is inside JMRI. Like LocoNet, like NCE, Lens, CMRI, all sorts of others, there's a connection page. So that's where you put the details for JMRI to know where these messages are going to go. So the key items in there is the IP address or the host name for where the MQTT server is. In this particular example, I've got the MQTT server process running on the same computer as JMRI, so I can just use the name localhost. That means it's the same server. A little bit further down there is MQTT channel. That's just a name that was invented. It's not really an MQTT specification. It's just the first topic. If you're using this MQTT system, sharing it with your home automation system, as some people do, it just helps to have them neat and tidy by having different topic structures. So MQTT base topic will identify, separate those from all the other stuff. So that's just housekeeping. A bit further down, there's different device types. So that will contribute a part to the topic. So you can see how it's building up the topic as we go along. So there's turnouts, there's sensors, there's lights. I can't read these properly on my little phone, but the last couple there are signal masts, signal heads, but they're not defined in JMRI yet, so we can't use those straight from JMRI at the moment. And then when you create a new turnout, it's just like creating a LocoNet turnout or NCE turnout. You put in a little hardware address. In this case, we have a code that identifies the node that we're using, and then the /01 will be the pin identifier for that node. So that's how we identify the specific one. Okay. Yeah, so messages are being sent backwards and forwards. JMRI is publishing messages about turnouts when you want something to be done. They go into the MQTT server, and all the other devices will be subscribing to those topics. You can have, it's not necessarily a one-to-one communication, so you can have multiple devices that are listening to the same topic, and they can all do something with that topic if they want. So there's a lot of flexibility in MQTT in that regard. In the case of sensors, the message is being published by the MQTT trains device that your sensor, it could be an occupation detector, a push button, it could be anything. So that just sends a message to the message server, and JMRI is subscribing to that, so it sees those messages. So the message is going backwards and forwards, as simple as that. And it gets a little more complex maybe if you wanted to do fancy things, but basically it's just messages get sent depending on whatever events happen, and any party that wants to know about that event will just subscribe to that, and then it can do what it wants to do with it. So we'll move on. Now, how about we look at taking JMRI out of the equation? This might work. I'm not talking about operation sessions now. If we're looking at more simple things, we might just replace JMRI with some sort of device that has the logic associations. So it's just watching whatever messages are coming through to the broker. So it'll subscribe to a whole lot of topics. And whenever it sees a particular message that it has a logic defined for it, so if this message appears, then I have to do something else. So it will publish messages for whatever it needs to be done. So it can just, like all the other things, it just receives a message and sends a message back to the broker. So then that might be a route selection. So it will send messages back to each of the devices that have the turnouts to control that route. We can change that a little bit more if we want. We don't have it at the moment, but the MQ Trains little ESP device could have some extra logic built into it, so it can make its own decisions on what it needs to do. For example, if it was a route, it might know what route it is. It might know which turnouts it has for that route, so it might just throw those points straight away. So that's getting a simpler case. You might want to do something like that if you've just got a small location that you're using. You might be playing with that during an exhibition or something, or maybe that's all you want on your home layout, just something simple for simple control. And one example is a staging yard. This is a project I'm working on at the moment. You can have any size staging yard. In this example I'm using here, I'm having 5 roads in the staging yard. And people like to have a push button to select which track they want to go to. Because working out which turnouts have to be closed and thrown gets a bit complicated. It's much easier to just press one button and say, all right, that's the one I want. So how do we do that with MQ Trains? So you have your control panel, wherever it's convenient to have your control panel with your push buttons. And let's have a look what goes underneath that control panel. We have your push buttons. We have one of those MCP boards, so we can have up to 16 push buttons on that. We connect that to the ESP01 device, and we have 3.3 volts power. And that's it. There's no more wires coming in or going out. So often if you look underneath a control panel, there's a massive wires going out to your layout and coming back in and whatever. So we just eliminated all those wiring issues. So we just send a Wi-Fi signal to the yard where all the servo drivers are. So you use the same servo driver like Speed showed earlier to drive whatever servo motors you've got to drive your turnouts. So that's the logic as it goes, right? MQ Train detects that the button's been pushed, so it'll publish a message to say it's been pushed, goes to the server, to some sort of logics controller is going to be looking for those topics. So it sees that button's been pushed. All right, so now I've got to turn point number 3's got to be thrown, point number 7's got to be closed, whatever it is. So it will just publish those messages. And then you just have an ordinary servo driver to drive your turnouts at the end of it to throw all those points. Now, what about modular systems? Let's talk a little bit about modular systems, and there's nothing more modular than N-scale T-track. I'm sure people have seen it at shows. There can easily be hundreds of modules. Sometimes they're small, sometimes they're bigger, and they're usually much smaller than other ones. In this example, I've taken 3 standard size T-track modules. So that's about 1 foot by 1 foot, 310 millimeters long to be more precise, or 300 deep. Standard size T-track module. Let's take 3 of those and put them on the end. You don't really want your track sections to be 1 module long because your trains are going to be longer than that. So it's going to be more practical to have a longer section. So in this example, I'm saying let's take 3 modules. They can be straight modules, corner modules, double length modules. They can be anything. So they're just standard T-track modules. Now what we do is we put the isolators. So take out the uni joiner on the end, put in the isolated uni joiner. It takes about 5 seconds to change those over. So now you've got those sections isolated. So I've got 1 section on the front track, 1 section on the back track. Now, once we've done that, let's add some power supplies. Now we have each of those lines represents a pair of wires. So we have the red pair that goes to the rear track, and we have the white pair goes to the front track. And it's good practice, not essential, but it's good practice to have a power feed in each module. People in America, if there's anybody from America watching at the moment, they think, what, red's going to the rear? Yes, that's what we do in Australia. America, they have red to the front and yellow to the rear. We're different because we like to be. There's a long story behind that, but I won't go into that now. I've got electricity. Things are happening. Distractions. Let's move on.
Block detectors?
Yes, we just added block detectors. All right. We add a block detector onto each block. Now, we put that in the track feed into that track. We have 2 tracks, 2 sections, so we only want 2 detectors, 1 for the front, 1 for the back. Now, what do you do about those other 4 wires? Now, you could just not connect them and rely on the track joiners between each of the modules. So you only have 1 detector per section. That's the golden rule, 1 detector per section. But we like to have feeders to every module. So how do we do that? We connect a wire to the output side of one of the track side of one of the detectors. In this case, it's the front track. So we have a wire coming out to the back. So normally those wires out the back will join to the track bus along the back. In this case, we have our own little bus that goes across these 3 modules. So it will plug into the ordinary connectors in the other 2 modules, and this one is coming out of that track. And we do the same for the other module. My phone's going crazy now because there's network stuff. There's all sorts of things going on. Now, all right. So now we add signals to this. We drive on the left in Australia, so we have signals at the start of the block. So we're going from left to right on the rear track and from right to left on the front track. So we'll put signals in there, which is just convenient having it at the same point, the same module as the block detector for that section. It doesn't have to be that way. Oh, the television's come on by itself. This house is haunted now. What's going on here? Okay, so we've got signals. Now we add the ESP device. So we have a wire coming from the ESP device to the signals and one to the block detector. There might be an MCP board there as well. And of course, they only talk on Wi-Fi. So they will go back to the MQTT server and send all their messages back. So what have we got there? We've got in the middle, we have a stock standard T-track module. Nothing else has changed. You can put 2, 3, 4 modules in there if you want a longer section. It can be as long as you need. So on the other 2 modules, what have we got? We've got 1 extra track connection coming out from the block detector, and we will need 3.3 volt power supply. That's it. So however many, you might have more blocks on a module if you've got a more complicated arrangement. There's no turnouts there, obviously. So if you have some sidings in there, you might want extra blocks. Doesn't mean extra wires. You just got power supply in it. And before you know it, you're going to have a complex control panel, more complex control panel, and you're ready for operations, just like the big league. So that's two-track. Now, JavaScript is a little bit different. Some people like to use JavaScript instead of other languages. So maybe I'll consult an expert who can talk more about JavaScript.
I'm not sure about the expert, but I can show you how I did it. So with JavaScript, that's the code that just simply lives in a web page. And first a few pictures to show that there's a tablet mounted. And inside of it, I just go to the hump yard entry point, .html. And then there's JavaScript code that determines by subscribing to the MQTT broker to determine which track is selected. And you can see those cars are running down the middle because the blue button in the middle shows that we're going down the middle. Now, if I select any other route on that screen, then the servos down there will change position and the next cars will be humped down a different track. Or you want your dispatcher to have access to a bigger part of the layout, and then we show him with little red lines where the trains are. Now, he doesn't know which way they're going, but since he's been watching them, he could tell that the train is about to enter Okahanya towards the right. And of course, since we do left-hand running in Namibia as well, that train on the helix, which is right above my head here, is going upwards on the outside loop. Here is the panel I will show you close up. That's my hometown, Okahanya. And you can see the tablet on the right there with all the turnouts in town. Whereas if we go back to the one before, you can see the area to the top right where Okahanya is for the dispatcher. He doesn't get control over all the turnouts. But the guy locally in town operating there, he has a few more points that he can move. So when we zoom in and we look on it from a computer, you can see here's all the turnouts. They are simply icons. I borrowed these from JMRI, added some beautiful orange circles to them so that you know that that's where your finger needs to go. And bottom left, you can see that train has progressed now. It's on its way to Windhoek to the left. So that white image have changed into a red image. Okay, so why would we do this? Well, if your website is public and you bridge the MQTT brokers for your dispatcher to host it, then to use it, then you don't need any firewalls in your any holes in your firewall to make this work. So you solve that whole problem. When I got into this, JMRI only had MQTT turnouts. We subsequently added our own sensors and the virtual masts, but I was on a short time frame to get it all working. So the JavaScript way was a lot quicker. And I also found the web server pages from JMRI in 2017, 18, and 19 was not as easy to use. They might work a lot better now. So try those first. But why don't you just install a small web server? I use Light TPD, download a few JavaScript packages, MQTT WS31 and conva.min, that's the graphics thing. You draw your own images, you create a few functions to subscribe to MQTT topics and publish when you touch or click something, and off you go. So literally what's happening is when the user changes an element on the screen that has a topic, then it will change its state, meaning publish the other image, and then publish it also to the MQTT broker so that everybody else who needs to know can get the message. And when it's subscribed to things, then when they come in, it will find the element that matches that topic and update the element. You see, it's all easy. So here's literally the Okahanya HTML page top part. There's a whole bunch more images in it. So the list continues all the way for about, I think, 50 lines. But in the beginning, you include the two libraries. you in the body of the HTML page, you provide the subscribed topics. I'm going to two boards, 0021 and 0023 for servos, and for sensors, it's 2003. You got to give it a name, because when you connect to an MQTT broker, you want to have a unique client name. And then the three elements I showed there are the three elements in the bottom left of the screen. The first one is image index 5. That's the blue line that represents the main line for the dispatcher and the local operator to see. The second one is connected to the sensor. That's the white line that just turned red in that image. And then key number 7 is the servo, the first servo on the 21 board. So the left-hand side shows you the end of the HTML page itself, where you create the canvas stage to tell it how big in width and height it needs to be. You have to say if you click this or if you tap this, because clicking with a mouse and touching with your finger are two different events. Then we simply run this function called do it, something that I created myself. So you'll see that in a second. Then we load all the images as they were pushed into that array, and then we add it to the stage. We set up the client. That function is shown on the right, and then we get the client to connect with some options. The function on the right is in the txn.javascript file, and we simply generate a random number so that we can connect to the broker with okahanya dot I thought it was some random number. Yes, some random number. And then we define two messages or two functions for when the connection is lost, do a certain function, and when the messages arrive, run a different function. So the client name could be okahanya.14531, and when you reload the page, that number will change, so it will look like a new connection to the broker. So you could literally have all 12 tablets and the dispatcher and your phone and the 4 other operators connect to the same web page, and they will look like all different clients, and they can control and see the turnouts move when anybody else touches or when anybody touches them. So the function do it, the first thing we do is we check if we connected, because if we're not, then we're going to show you an error in the bottom in red there. Sorry, not connected. Refresh the page, please, because they do time out, and you don't want to have permanent connections from devices that's not in use anymore. So the next step is to see if the element has been locked, because a white line that never gets a sensor to it, you don't want it to change colors. So it's just set up to be locked. Then you check the state of that element, and you change it from true to false or from false to true. You show the appropriate image, and then in the publish line, you've determined if you need to send a thrown or a close for when someone touched it. On the message arrive function, that's when either you press it or someone else is pressed or the dispatcher touches a turnout. Then the message will come in. We will see if it's a good topic. If we have a match for it, we check if the payload is thrown or active, and do something with the element. Or we make sure if it's closed or inactive that we do the reverse, and then we redraw the image and end of the function. So what else you need to do? You have to take care of when things disconnect and things time out. And the next on my to-do list to make this a little better is so that the dispatcher could lock a turnout, and then something for you to ask him permission to use the turnouts in town. And then how about while you're there, show the train and which cars need to go where, which ones you need to pick up. Oh, wait, that's not on topic. So I think we are 3 minutes late. So if there are any questions, this is MQ Trains' last show for this weekend. So you have to ask those questions now.
And David, so just let me rework that into there. So great presentation. You make it sound really cool and great, but for some of us less tech savvy guys, is it really that easy?
Stop right there. Can you swivel your camera so we can see your little implementation there to the right?
Unfortunately, no, but okay. It is really that easy. These guys aren't making it all just jargon. It's quite simple and it works really effective. We do have a couple of questions in the chat now. David North, I see, has dropped in halfway through the clinic, and he asked, "Does this run with JMRI?" You guys?
Maybe. Yes,
Maybe?
indeed.
Of course it does. It works really
Yes,
well.
it does, but it doesn't have to. It can be whatever else
Yeah.
is wants to control things.
Okay.
It is fairly new in JMRI, for new features. So we always tell people download at least the latest. And since it's also cutting edge, you might also want to go with a developer edition that's a few more weeks or months newer than the standard version.
Okay. Thank you. One of the other questions that came in off, I'm just trying to have a look where it came off YouTube, I think it came off, was how does this different from CATS?
So CATS is the automated train system, which plugs into JMRI to do automated train running and setting routes and setting signals. We are on the other side of JMRI, where we do the physical work of changing signals and changing servos and reading sensors. So CATS would certainly benefit from this if you have JMRI in the middle.
Okay. And the last question I see came from Jeff. He's down here in Australia. He asked, is this similar to Hans Tanner's IOTT?
There are some overlap. I believe Hans has his original project was taking Digitrax LocoNet packets or data and put that onto an MQTT broker so that you could see all the packets that go on your LocoNet. But I believe he's done also a lot of web page setup things to drive signals and things. So I have a suspicion that it's all going through a Digitrax connection to your JMRI, but pretty similar if you look at the end result of how you get signals to change colors or aspects.
Okay.
With MQTT, you don't even have to have Digitrax. Oh, sorry, you don't have to have DCC at all. I'm working on a staging yard for somebody who's running a DC layout. And we'll use that just to control the turnouts for you.
Okay. I just want to show something. I know, David, you mentioned that you'd like to show them just exactly how big these ESP boards are. So I'm not sure how well that's going to pick up, but they are literally the size of your thumbnail. They're tiny, and it kind of amazed me.
Here in the States, they also sell them in a starter kit at Micro Center here in America.
Yeah, 1/3 of the size of that is the antenna, 1/3 of it is the 8 I/O pins, and the middle third is the rest of it.
Correct.
That's the size of a little fingernail.
So guys, there is one other comment in the chat before I thank yous, but Speed, Ralph's asked when are you coming up to Toronto to set up his layout, and before you chime in, I'm going to say, Ralph, be careful what you wish for. You might end up with a pile of electronics.
I was going to say if they open the border so we can get trees, then maybe I can sneak back in.
Yeah, good answer, good answer. Okay, guys, I'd like to thank you, and David, I think you probably want to go and turn that heater up after sitting there for 60 hours.
I reckon
no power,
so, now that I can. I'm looking forward to that.
So thanks for another great clinic, guys. Everyone else will cut to some ads, and before our next one, I think we might have a quick sneak peek at some remote operations over at the Silicon Valley line. So, Speed, David, thanks very much.
Thank you.
Cheerio.
Okay, welcome back, guys. Martin, I believe we've got a little sideshow event going on at the moment behind the scenes for this convention. The guys over at Silicon Valley opened up their layout and let a few Aussies take over and rampage the place, I heard.
That's correct. I believe there's a couple over there running already. So if you go over to the meeting room, we'll have the Silicon Valley line shared there, I believe.
Yeah, so what I think we might quickly do, Martin, if you don't mind, we might cut over now and just give everyone on the stream now a quick sneak peek of what they could be seeing.
Let's go and have a look.
Alright, so this is direct out of the Silicon Valley line feed. So as you can see, this is a full remote ops setup, and by the looks of it, it looks like Duncan has just been operating a train. I believe, Martin, you were over there watching just before.
Yeah, over there before, and I saw Duncan and Philip were out running, so I'm just, unfortunately, I just dropped the feed. Yeah, no, Duncan looks like he's stopped in the yards at the moment, so...
Yeah, it looks like a few guys are just moving a few trains around now, but like Martin said, we'll put this feed over into the lobby, and I'll also put the link into the chat. So if you want to have a look at a bit of remote ops and just some basic train movements, that'll be over there streaming. But we'll be back very, very shortly with the next clinic.
Okay, we're back here in the studio, and we've got our next clinician, Richard Bradley. He's got a recorded video. Richard, he's had extensive experience in signalling for New South Wales Railways. Presently, he's retired. Nearly 53 years experience for railway signals. So it looks like we're going to get a good little talk on railway signalling at the moment, and doing track plans, safe working rules, procedures, as well as investigations as required. So I think Richard's got quite a bit of experience with railway signalling. So without any further ado, I'll hand it over to you, Richard, and you just let us know when you want to roll the video.
All right. I've also got nearly 60 years experience in motor railway signalling, including 4 years on the Royal Easter Show model railway at the showground. I've also been in model railways for nearly 70 years. You can roll my video now. The object of this is to teach you how to signal a layout. We have a standard crossing loop you find on any single line on many railways in the world. It's got a platform, and we've also added a level crossing. The signals in principle should protect points, platforms, level crossings, a train sitting anywhere on the layout. So we add the first signal. Facing points. So we put a signal in for the main line. The signal also tells the driver which direction he's going, so we have to put, or we don't have to put, a turnout signal. We do the same at the other end. That's protected the points from trains coming in the facing direction. To protect the section to the next signal box, and to protect the points from run through, we also put signals to come out. Now I'm doing this for Australian principles, so the signals go on the left hand side, but on a crossing loop you haven't got much room in the middle, so you put the signals on the wrong side. Now we've also got this level crossing. Depending how far it is out of the station, whether we want to protect it by another signal, or if it's a long distance out, we can let it be automatic. Now to warn the train he's coming in, if the signals stop, we want to, braking distance behind this signal, we want to give a warning signal, which is a signal but it's not a signal. It's a distance signal which has a fishtail arm, and out this end somewhere we have a distance signal. Right, now what the signals protect. First thing we do is number our signals. 1, 2, 3, 4. In that direction. We number our points. 11, 12. We come back the other way. We've got 14. We have 15. We have 16, 17, 18, and the distance signal's 19. Now by principle, this distance signal warns the train that there's a signal in front of him that is at stop. So 1 equals 2 clear, 3 clear, and 4 clear. If any of those signals are at stop, one has to be at caution. In the other direction, it's exactly the same. The turnout into the loop, one does not come off. It's a lower speed signal, so the driver has to be warned that he has to reduce his speed. So this one here, which is 5 and 6, let's say, and the same in the other direction. Sometimes in a case like this where you've got what's called an outer home, they sometimes put a distance signal on it, and in that case 19 checks 18 and 17, and this one, which we'll call 20, it checks 18, 17 and 16. Now number 2, it equals 11 points normal or closed and 12 points normal or closed. Generally, it also equals 16 at stop and 17 at stop. This, we have signalled this layout now. I have mentioned how the signals detect or interlock. Now we have here, we have what the professionals put in the principles of signalling for exactly the same layout. And as you see, that they are virtually the same, because I followed the principles that I was taught, and this is the answer sheet. You'll also notice that at the bottom is what's called the locking table, the levers which control the signal, and what the signals lock and how they lock it. These ones here with the W's in them, that's special locking, which will be dealt with at a later session. The interlocking will be dealt with at a later presentation at this virtual convention. Now we come to a model railway layout that exists. This is Coleroy interlocking on the Coleroy and South Creek Railway. I have already signalled this on the plan. These signals will be installed later in this presentation, but I just want to mention that that's how it's laid out. You start with the home signal, got the mainline signal down main. You have a turnout into the back platform. You have a turnout into the up main platform. The other end of the platform you have a mainline signal that goes straight up the branch line. You have a turnout signal to go across to the down main. You have a turnout signal from the down main across to the branch. You have a mainline signal to go straight down the down main, and it's the same. These two signals do the same. You have a home signal up main platform to up main, and a home signal down main platform to up main. We still have one thing left. These 4 signals protect this level crossing. This is an automatic level crossing but it's semi-automatic. For the branch and the down main, it's semi-automatic. If the signals are clear, any of the signals are clear, and a train pulls into the platform, the crossing will start automatically. If there's a train approaching on the branch or in the up direction on the down main, the level crossing will start automatically if the signals are clear. For the down main, it should be fully automatic, because there is no control signals. Because there's no points, there's no control signals. But we have a route to come through here up to there. So what we have to do is we have to put a signal before the crossing to protect the crossing, and we have to put a signal here to protect the platform, because if you have a train sitting in the platform, this is a section, you don't want a train to come in. But they also sort of protect the level crossing. But normally this is signals in automatic, so the train just comes along. When it hits here, this crossing starts. When the back of the train gets off the crossing stops. So later on I will be putting the signals in for this, but I will be using New South Wales colour light signals. Now I have signalled this. I'll be using New South Wales signalling. At the present moment I've marked it up for lower quadrant signals, the distance, which aren't showing on this diagram, the home signals, which are single arm, and the facing junction signals, except for one of them I've got another dolly out here. I'll be using New South Wales signal lights, double light colour light signals. They will be, what I will be using is 6 light colour light signals for here, here and here. I'll be using 5 light colour lights for here and here and here. And so the indications for New South Wales are 2 reds for stop, green over red for caution, green over yellow for next signal at turnout, or next signal at caution, or a signal within braking distance at stop, and 2 greens for all clear. For the turnout routes, you get yellow over red for the next signal on the diverging route at stop, and 2 yellows for nothing at stop within braking distance. Yep. Alright, now we have these signals here. I'll be using a upper quadrant signals for that. I've had some converted from Victorian to New South Wales by putting a lower red green lamp case on, and they show arm horizontal red over red, arm 45 green over red, arm 90 degrees green over green, and turnout the arm only goes to 45 and they have a fixed red, except in special cases. So I'll be using these there. I'll be using these double ones here. I'm actually using Hornby solenoid operated signals for those two. These are our 6 light colour light signals, and that's how I'm going to signal the layout. After you've decided where you're going to put your signals, you have to decide what signals you're going to use. Now I have here a chart of the commonly used signals in Australia, starting with the New South Wales signals. Single light, where double light, which is what I showed you earlier. The Victorian and South Australian signals, where they don't, where they use the top head to indicate the train, where the train's going, where the train is, and the bottom head to indicate any special speed restrictions or directions. We've also got the Queensland and South Australia, which virtually almost use the English system. Western Australia, English system. They also have special train order. We have in New South Wales we have train order signals, whereas the green is replaced by a white light. Which flashes. And then we've got the ARTC train order, which is different outside New South Wales. In New South Wales they use the New South Wales system. In the Western Australia and Victoria they use two different systems. For those who want to use mechanical signals, Dapol make a range of signals. These are bracketed signals. They work very well. I have used them. Actually they're brand new on the market, but I have installed them and have had them working. They make the signal which you've got the distant, and it also comes with the home. These come in O, HO and N. The present moment these only come in HO, but the signal ones have this motor on them instead of the solenoid motor. I am using these. They're made by San Mateo in Victoria. They seem to be pretty good. I've got them on trial on the layout. They are leads, so therefore with all leads you have to have your resistor. For upper quadrants, New South Wales, we have these, which San Mateo made specially for me. Their normal Victorian signal has only a red marker light. I asked him to put a shunt signal on this one, and I asked him to put a red and green marker lights to imitate the New South Wales system. You only get the signal, you put a servo underneath to drive the signal arms. Servos, right. Those who are signalling in England for colour lights, they make a range of colour lights with the little activator logic circuits that will drive them. Instructions are pretty good with all those. So that's that. New South Wales, you can also get these made by a Tasmanian company. They come in single light, they come in double light, and they will come in 3-on-3, 2-on-3, shunts, singles with red markers all set. They require a switchable DC supply because they have a limited number of wires. Now, to drive your points, that's another thing in the signalling system, is points. To drive the points, I use tortoises. They're a little bit expensive, but I've found them over the last 20 or 30 years to be very reliable. I've only ever had 2 go defective. One of the problems you can have with them is if you drop them hard, the cogs inside will lock up, and then the recommendation from Centratron is you bash them hard and get the cogs back in. The screws to open up, it is actually an electric motor that drives a gear train, which drives a quadrant, which drives this drive shaft. You have a fulcrum, you have a screw and a throw bar. You put the throw bar and the screw in there, the fulcrum there, and then you poke it up through the layout with your points on top. If you they work off DC, DC onto 8 and 1. You can run detection on your points, which detects which way your points are. That's those 3 and those 3 contacts. With this signal, if you connect the common wire to terminal 4 and connect the other 2 wires respectively to 2 and 3, when the switch machine goes over, your arms will literally change from horizontal to off, alternately. Now, the tortoise has a new update. It's called the snail. I have put it on an adapter plate, and with a tube. This adapter plate is used to drive upper quadrant signals, but I've gone to the other method. But this has the advantage is it works off DC the same as this one, but for DCC with the tortoise you need a accessories decoder. With the snail, the accessory decoder is built in, and it's such that when delivered, this is exactly the same as the tortoise. It's a DC, but by, can you see the button? By pressing the button, you can program it to be DCC driven. Just put the number in, and by changing the CVs in it, you can make it free position to drive a free position upper quadrant signal, or free position something. And that's now the drive. You can also get an adapter which goes under the points that will drive up through the layout to drive the points. and they come from Circuitron. Circuitron, to drive, you can also use this little blue thing in here, which is a servo, one of an adapter plate, and it can be used to drive, it can be used through the layout to drive your points, normal and reverse. There are other methods of driving points, Pico make motors, Impulse, Atlas make motors. Now when you get to the next stage on your layout, you might want to detect the position of these points. As I said, you can use the contacts on your tortoise. You can mount contacts, micro switches on your servos. You can mount micro switches on your points, and as it switches and changes the signal, I'll show you that later. Now, track detection. If you want to go, most people don't go any further than that. If you want to go to detect your train on the rails, we go to the next stage, which is our track detection. You have two rails. You put a brake in one. You come out to a black box, which then feeds out to your signaling system. This black box can be a little module made by NCE. It's called a DB20. It's got 4 terminals. You connect a input unit common to the 4th terminal. You connect your switch to the 3rd terminal, and depending on your configuration, whether you put a positive and a relay on these two is depending on you. Now you can use one of these, and with those you come off the rail, you put a loop through that half moon thing or 2 loops through there, and then you go to your bus bar. You only have to that will detect most DCC locos, most lighted wagons. Chubb and his computer model railway infrastructure, he makes a kit which is exactly the same. As you can see, you have a printed circuit board, you have one of these Hall's detectors, which is just a loop, and all you've got to do is you feed the rail into one, the bus bar into the other, and you put positive and negative on the other. But virtually what you're virtually doing with these is you're virtually putting a amplifier on that, and then that feeds to the signaling system. If you're using DC supply, you can't use that. You have to use what's called a twin T. And that is virtually 2 transistors connected emitter to base, and the collector goes off to a amplifier and then to a relay. These work very well. You get adjustment with the Chubb ones. You get adjustment. With these, you can output into a Chubb input card. You can input into a NCE AIU1. Inputs are down there with a common on each of them. You just run, I've used telephone cable from there to there. It then feeds into your control bus of your NCE system, or the Chubb one will feed into your control bus of your Chubb system. In this one it goes into your command station, and you can use Panel Pro or one of those programs to read the inputs. Now, there is, for you people who use FreeRail, and this will also work for DC2 rail, you can virtually, with FreeRail, with your third rail, you can isolate that, take that out to a relay, put plus 24 volts on there. You take that one to earth, so you'll have your traction supply between that and the common rail. That relay works very successfully. I saw it used at the Sydney Royal Easter Show on their big HO gauge model railway. I saw it used on their O gauge layout. It worked very well. For two rail there is a problem. You've got to get your traction in, and for two rail you use a pickup contact of that, and you either use a diode or a drop contact of the next track circuit, and then you put your traction onto there. When the train comes onto the track, the relay picks up, puts power onto the track. It's almost instantaneous. When it gets off into the next one, this relay opens, cuts the traction off, so you've got an automatic braking section. It's very effective on two rail, but I prefer, because I'm DCC, I prefer the electronic versions. Cyclotron make a whole lot of interesting bits and pieces. They make track detection using little light resisting resistors. They have little modules which you connect them to. You can adjust your light level. They also make them with you've got your section of track, which is your block. The train runs in, trips the first one, nothing happens. Trips the second one next to it. It puts a ground on the output. The train runs through, trips the third one, keeps the ground on, moment the last vehicle gets off the fourth one, the grounding on the output comes off. Some of the units, it drives the signals directly. Some of the units, you have units for your signals that will drive your signal indications, level crossings, and you use that negative feed in to change your lights. But if you go onto the Circuitron website, just Google it. It's got a very good comprehensive list. But I use the DT4s to detect the back of the train, because if you've got your train on your track, your block, in 2-rail, your caboose guards van has insulated wheels, so this does not detect the guards van. But if you put a light resisting resistor in there, light dependent resistor, and wire it into your signalling system through one of these units, as the train goes across, it puts a shadow across and no lights hits it, or very little. But when the guards van caboose gets off it, or the last vehicle, the light comes back onto it and turns it on, and then you've detected the back of your train. It's very good for the Australian people. It's very good for trains like Indian Pacific with 14 passenger cars. You can have a complete signal change up to full green halfway through the train. So that's what they're for. You can drive relays. This is a relay. They are commercially available. They have a coil, and they have either one changeover contact, 2 changeover contacts. This one has 4 changeover contacts. They come in 12 volt, 24 volt and 48 volt. You really only need the 12 volt ones. NCE make a unit for the driven by the point motors. It's a tiny little unit. The relay is about that big. Those relays, if you want them separately with 2 double pole, double throw, are available from your local electronics store for about $5. The thing is, it takes a lot of wiring to wire one of these, to wire a signalling system up with one of these. In the old days, we used to use telephone relays from telephone exchanges. You also got to watch with these relays that when you turn the power off to them, you don't have anything between those 2 terminals. They do have a kick. I have recently finished relaying this junction, and now it's time to signal it. I will be going through how to signal a layout, starting with a simple one, but this is the junction I want to signal on my layout. Pretty simple junction. Main line coming in from the wherever up to the points. We haven't finished the wiring yet, but this is how it goes. Now we have drawn up location of where our signals are to go. We now decide on what signals we're going to use. I model New South Wales Government Railways signalling, so therefore we're going to use the New South Wales Government signalling signals. For this area we're using colour lights, double head, and we're using banner signals for the sidings. So that brings us into what we're using. So we are going to use these signals. They're made by San Marino Line, the company in Victoria. They make it in 2-on-3, 3-on-3. They also make upper quadrant signals, which I use elsewhere on the layout. I'm also using as banner signals on the sidings. Now we have to drill the holes for the signals. Now generally for most signals, colour light signals, you get on with a little hole to take the wires, but that can be dangerous in that if you go to pull the signal out you can break the wires. For semaphore signals, motor worked, and these, you have to drill a 14-inch hole, a 14mm hole. Sorry. So a 14mm hole will take the barrel. So generally it's probably wise to drill a 14mm hole for all your signals. For the upper quadrant signal it looks like a lot larger hole. I'll get to that later. We go about 6 foot out from the station, about line with the points, and there's there. Right. I have now drilled 1, 2, 3, 4, 5 holes to put the signals in. Now all we have to do now is mount the signals. By the way, when drilling, make sure there are no wires or switch machines anywhere near where you're drilling, or you can have a catastrophe. We've drilled the holes 1, 2, 3, 4 for the signals. Now we've got to clean the mess up. We use our handy vacuum cleaner. Always handy on the layout. When drilling, make sure there are no switch machines or etcetera anywhere near the hole, or you'll drill a hole and wreck some stuff. Right, that's got the layout clean. Now, to mount the signal, you take the signal, you thread the wires through, and set the signal down. This one takes a square hole. So you grab your signal, free light, colour light. Free light, colour light goes over here. Open the packet. Undo your wires. You notice these have a resistor on. You then poke your wires through the hole, and you see that the hole's too big for the wires, but that's okay. It leaves you plenty of room. You settle your signal down. Your signal's is in place. It's close to the point of the switch. This one here, there is a 2-on-3. A 2-on-3 tells you stop, caution, medium and clear. The 3-on-3 I just put in tells you you've got a turnout to go through in the throw-in position. In the case of that one, it's in 2 throw-in positions. So that one then goes in there. This is for demonstration, so normally you would have another one over. Now, we've mounted the signals. We have a 5-light colour light for the up main. We have a 5-light colour light to come out of the down main onto the up main. Because there are no movements, normal mainline movements from the back platform onto the up main, we're using a shunt signal to go down the main or into the siding. We have a shunt signal to come out of the siding, and we have over here we have a mainline 6-lighter, top yellow to go into the back platform, top yellow to go into the down platform, the up platform, and top green to go into the down main platform. One more signal to be added, and it's a special little one. It's made in England. Right. Nice little signal I just came across. You've got to do a small assembly job on it. So you do a small assembly job on it. That goes there. Goes there. It's got terminals that you wire to. Instructions tell you how. and can be a bit tricky at times. As a finishing touch, you can add to your layout a signal box to control it. You can also have a signal location where all the signals are terminated in on the layout. But as this is a electric layout, electric points, little point motors there, oopsies. Point motor don't have to have a signal box, but definitely have to have a signal hut. Well, you don't, it's just a bit of scenery. You can have boxes, troughing. Don't generally put rodding to control the points if you've got the electric motors. These electric motors are separate to the ones underneath, which we are going to go to now. These are tortoise switch machines. They are mounted straight to the bottom. You drill a 1/2 inch minimum hole under the throw bar of the points. These have as you can see, they have a fulcrum, a wire that goes through the layout and comes out. You control them in DCC by decoder that controls 2 points. Here's one by NCE that controls 8 ends. And remember, with tortoises it's better to have each switch machine wired off a separate output, even though the outputs will take 2 switch machines. That is a Circuitron snail. It's virtually a tortoise with the decoder built in, so you don't have to supply a decoder, it comes with it, and it's got some decent terminals on the end. This one can also be programmed to go into free position. Here we have a snail that has been mounted on a semaphore signal control and activator, and is programmed for stop, caution and clear. They come with the fulcrum and the wire, so all you got to do is pop them in.
Button.
Thank you.
Double red. Green. And it works the other way. 2 double red. And that's it. Double red. Now it's got the inner track, so it's gone to green. And it comes back. Yep. To the other signal, we get that one down there, and they both go to red over there.
we get that one down there, which is that one. Biggest problem with signalling, getting people to understand what red and green are. This is the end of the loop. Double red. Until it gets there, then it goes to green. Double red.
Okay, so welcome back everyone. We've got Richard here. That was a rather informative clinic on signalling, New South Wales signalling. I say those San Martino or Marto signals from down in Victoria. There's a nice selection of there. I've got a couple of those myself that I've got to put together yet. So let's have a little look in the chat. We've got a question there. Well, Speed's asking, where would you get the copy of the signal indication sheet you showed? And do you know if there's any sheets available for other railroads? Oh, you're on mute. You're on mute there. Hang on, we got to rewind. You're on mute. Jerry, if you can push the mute button. There you go.
Okay.
That sheet, which one? The first one was publicly given out at one of the Royal Easter shows, but it's actually from the Erskine Signalling Training College. There's probably a PDF of it around, and the second one was a special one done by the signal design manager in Sydney to show back when we were Rail Services Australia, which was a branch of the New South Wales Government Railways, and we're doing work in South Australia and the other ones to show any designers what the other indications the other states were. There's probably a PDF for that around at the moment. I'll have to get back to someone on that.
Okay, and we had another comment or question come in. I'm planning to model Albany Harbour Railway in Western Australia. So if anybody has anything on that place, to send a message off to Crafty Method. So I don't know if you know anything about Albany Harbour Railway. It's a bit far away from us, I guess. Yeah, that's about all the questions we've got in the chat there. And we're up to the hour, so thanks very much for your video, Richard, and your time. And we'll get the next presenter in here in a minute and put some slides up. So thank you very much. Okay, so we're back here in the studio, and we're heading all the way down there to Queanbeyan. Or we're not actually going into Queanbeyan because I believe Pat's actually in Sydney at the moment. He's at the Sydney N scale. So we might get a little sneak look around there later on. He just mentioned that they got a big layout downstairs, so you never know. We'll see what happens. But anyway, Pat's got a presentation here on the history of Canberra Railway. So welcome, Pat, and I believe it's a recorded video. So just let young Brad know when you want to run the Super 8 projector, and we'll get the video up and running.
Yeah, no worries, Marty. Thanks for that. So yeah, thanks for that. And the video you're going to see is just an overview of the Canberra Railway. It came about, I come from Queanbeyan and I wanted to model that station, but one of the members said, I'm doing that one, you'll have to do something else. Why don't you do Canberra? And I thought that was really boring and only one station, but once I got into the history of it, it was actually quite interesting. So when you're ready, can just roll the tape, Brad.
Okay, welcome back to NMRAx. We're now on the Australian run, so we've been all around the world, I think, today. They've been into Africa, they've been to Mexico, North America. So yeah, it certainly is an international one. Well, our next presenter is coming all the way from the Australian capital. For all of those in the US who don't know, it's not Sydney, but it's Canberra. And it's in central New South Wales, or southern New South Wales. And Pat's here from the town of Queanbeyan, just on the outside. And I believe today you're doing guided rail tours, and you've taken some time out to come and have a bit of a chat to us about Canberra Railway. So without any further ado, I think I'll hand it straight over to Pat.
Yeah, thanks heaps, Marty. I'll just share the screen and get the first things up. So yeah, unfortunately, I thought I was free on Saturday, but of course it's Sunday, 1 p.m. here in Canberra, and it's a balmy 38 degrees, which is about 100 degrees Fahrenheit in your language. So yeah, a bit hot. So I'm quite glad I'm going to have an hour off of train touring because it's very steamy out there. So yeah, so welcome. So basically I'm going to take you through the history of Canberra Rail. This is just a bit about me. I'm not going to read through it all. Basically I've done 2 years in Pakistan, 2.5 in Canada. Got to go down the east coast of America, as you do, to go to Disney World. So I've been through Carolina, Pennsylvania, and all those good places. Hadn't been near trains since about 13, just got back into them. 48 years old. I was in HO scale, I'm now an N scaler. Current president of the Canberra Monero N scale group, and you can see my favourite dog in the bottom left corner, affectionately known as Train Dog, who probably enjoys trains more than I do. He demands that they be run every night or he won't come to bed. Basically, I've got a 1.7 by 0.7 metre layout at home and recipient of the Brian Dwyer Memorial Award for the 1914 Canberra station, which you'll see later in the presentation today. I was involved in the convention and setting that up in Canberra for the NMRA, and I was a bit sceptical about the benefit of NMRA to young members. That totally changed with this NMRAx, which I think is a fantastic resource, and I fully support it. That's enough about me. You can ask me any questions from that list of interesting facts there later on. And of course, my last name, Gagel, pronounced Gachel in Holland. And Dad tells me that's like Smith over in Old Holland. So basically a bit of context for Canberra in terms of Australia's history. I mean, Australia discovered in 1770. The capital was originally formed following the Eureka Stockade down in Melbourne, which, but Sydney, there was a bit of a discussion about that. And of course, Australia was 5 separate states back in its day prior to Federation. Interestingly enough, we looked at the Canadian Confederated Provinces back in 1867, which essentially forms the basis of the Australian Constitution, quite ironically. So the first discussions about Federation started in 1880, and part of that was actually selecting a capital. They looked at multiple sites. For a long time, it was Dalgety, which was about 150 kilometres south of here. But finally, they decided that it would be in Canberra. Federation occurred 1st of January 1901. And that basically resulted in the setting up of the Senate, the House of Representatives, the Office of the Vice-Regal or the Governor-General, and the High Court. So basically the Australian Capital Territory was established because basically a capital city, and even to these days, need to have access to a seaport and strategically be located inland. Due to the squabble between Sydney and Melbourne, it was also stipulated that it had to be beyond 100 miles from Sydney. So that sets all the blockwork for Canberra to be established. The other thing is, so they launched the national competition, and of course, Walter Burley Griffin won that competition 23rd of May 1912. I'll just try and move this little window here. So in December 19, and basically he took it up, and we'll go a bit more into that detail. But Canberra's had a very checkered history in terms of major interruptions of World War I, the Great Depression, World War II. Even in Canberra building itself, you'll see through the presentation, there was lots of doubt at various times through history whether or not Canberra would actually happen or be built. And indeed, the bureaucrats responsible for Canberra never thought Canberra would extend north of the lake. Such was the lack of faith in creating this brand new city. And you can see a lot of our landmarks didn't actually occur till the 1960s, 70s and 80s. The most significant of that being the filling of Lake Burley Griffin, which didn't happen until 1964. It should have been filled in 1963. However, it was a drought that year. So when the Queen arrived in 1963, there were no lakes to be opened. So basically the requirements for Canberra was that it must have been in New South Wales, 100 miles from Sydney, needed access to a seaport, and it was for 2,000 people originally. Now, this is really interesting in terms of Walter Burley Griffin. Walter Burley Griffin being one of the early modernist architects who came across from Chicago after the war, and of course was good friends with a certain architect called Frank Lloyd Wright, who you might have heard of. Basically, the competition rules were to design a city for 2,000 people. And it was never published, but Walter Burley Griffin actually, in his mind, Reed was going to be a series of 5-story buildings with shops in the bottom level and living above. So theoretically, it is believed that Walter Burley Griffin's design could have actually supported a city of 2 million people. Now, when you're trying to attract people from Melbourne to Canberra, living in a city like Chicago or Paris was a bit daunting, and therefore it never got legs. And you'll see throughout this that there's lots of ideas that Walter Burley Griffin had, which were opposed by the bureaucrats. And as a little surprise, they left in frustration in 1920. So just a period of 8 years. There were some other things going on in his personal life, but that won't be covered here in this presentation. So as I said before, they initially looked around Dalgety. Yes, Canberra area was finally selected on the 8th of October 1908 by a vote in federal parliament, which at that stage was still down in Melbourne. They also purchased Duntrone Homestead for the military college. So what was going on around the times when they were designing Canberra? You can see Howard Ebenezer's Garden Cities diagram up in the left-hand side, and there was a few different proponents at the time pushing the whole Garden City ideology. You can imagine back at that time, they had the industrial cities in the UK, basically where they built cities for factory workers, fairly spog-bound, based on a grid. So this was a real radical new way of designing cities. The diagram on the right there actually doesn't look like the current ACT map at all, except for the 2 shapes on the left-hand side. That's the current shape, but originally they also intended to take into the catchment, which includes Queanbeyan. So they didn't partition that back when they created the ACT. However, the ACT still does hold water rights over that whole catchment. Hence, we've got a dam here called Googong Dam, which is actually owned and controlled by the ACT government. Down the bottom left is another idea, and remember this name for later. It's Robert Coulter. He was one of a local architect, urban designer, quite active in the area at the time, and was also involved in preparation of the competition guidelines. This diagram on the left is actually his idea. He thought it should be at Lake George because it was a very big water body. It's probably about 100 kilometres just north of here. Problem with Lake George is it fills and empties quite regularly. At the moment, it's probably about a third full. And the last time I remember it was full when I went to a swimming carnival way back in 1978. So not as glamorous, and yeah, you'll have trouble having water there the whole time, as pictured in Robert Coulter's diagram. Interestingly enough, Coulter also did these watercolour pictures of the Canberra area, which were sent to all the competition entries for the design of Canberra. On the right, there's also a plaster model, and you can't quite see it on this picture, but I'll point it out on a diagram further. But it's even got a presupposed rail line, and I don't think you can see my mouse, but yeah, it'll show up on laid plans. And the bottom right corner is actually the competition rule book that was sent around to various people wanting to enter a design for Canberra. So here's a plan, it reflects the plaster model, and you can see the dotted line going, squiggling up through the center of the diagram, which is where they stipulated the rail line had to be in the competition rule book. If anybody's worked as architects, and being one in a previous life, I suppose I can comment, they're not the most easy people to follow directions, or not the best, not one of their strongest attributes. So one of the features you'll see when we get to Griffin's design is he didn't adopt that route. So here's the winning entry for Walter Burley Griffin for Canberra back in that 1912, 1908 sort of time period. Quite artistic sketch. If anybody asks, they normally attribute these sketches to Marion Mahoney, but you know, there's no real evidence one way or the other. But anyway, it was the winning sketch. You can see it pulls out the whole idea of garden cities, different nodes, circular design, and linkages between centres. Very geometric and laid out on a geometric grid. The main axes actually line up with significant hilltops and mountains around Canberra. And this is just a bit of some of the perspectives that were entered as part of the competition entry, and just the whole sense of order around Canberra. Quite interesting, you know, Parliament in front of the people in the commercial districts, which stretched across from left to right in front of the Parliament, so they could always see the people they were representing. Of course, and we'll see some of the interventions soon, that never occurred, and Civic ended up on just one of the nodes, which is our city centre. So there's two really interesting design rules, and you can see where the intervention and potential sources of frustration start entering the picture here. So the bureaucrats saw the competition as supporting their own work rather than the other way around, rather than the architect or select winning designers actually driving it. The other bit, they saw the competition as a source of ideas to add to their own ideas that they already had. And one of the interesting things about Canberra is a place called Manuka, which on the Burley Griffin plans are called the initial city. The bureaucrats thought that was the best place for the city centre because it was in the lee of Mount, and I'm going to forget the name, but basically where Capitol Hill is now, and it was in the lee to the prevailing winter winds, so they thought that was the ideal city centre. Hence, we have a place here called Manuka, which is part of a suburb called Griffith, but you won't find it on an actual plan or a map because it was never supposed to exist, and to this day it still doesn't exist on a map, and if you put it into GPS it will tell you that Manuka does not exist. So anyway, so part of the conditions were that the permeating design shall become the property of the government, that restricted use either in whole or in part, and section 23, which said the government by its own officers will give effect to the adopted design. So that was taken quite literally, and shortly after the competition was won and run, they published this, which was their own design. And it is very interesting in that it shows the railway in the original configuration around the lake. Oh, actually, no, it doesn't. It'll be a later one, but this actually does use Burley Griffins, but they didn't like Burley Griffin's alignment. And it was heavily influenced by, and you'll notice this name is familiar again, of Coulter, who are entrance number 10. And you can see that their plan does include the railway in the original competition entry requirements, and why wouldn't it? They wrote it. and also the classic city problem of putting major infrastructure along the side of water bodies, which makes it really hard to access for people. So anyway, so the plan that the department came up with was a combination of competition entry 10 and Burley Griffins into a design conglomeration of the two. And here's the visual. You can see a bit of a Sydney Harbour Bridge thing happening there for the railway, and then a major traffic bridge. A lot of the designs did have the Parliament at Capitol Hill, and you can see maybe potentially an American style Senate sitting on the hill there. So finally, Walter Burley Griffin was brought back on board after mainly the professional bodies disagreeing with the department on their plan. And this is Griffin's plan of 1916, which was the final published plan. And he never published another plan before he left Australia. I think the date of this is actually 1918, not 1916. A couple of features to point out here is the railway line crosses what is called a causeway. So the lake on the right, which is never built, is called East Lake. It's actually 6 meters higher than the main lakes. And its main purpose was to bank up any debris coming down the river so it wouldn't pollute the lake. Anybody who's been to Canberra lately knows that if we get a lot of rain, the lake gets closed for sailing because you usually have to compete with big logs and trees floating in the lake. So this would have prevented it. But anyway, I can go through later why it wasn't built. Mainly it was people thought it would be ugly having a 10-metre high causeway across the horizon in Canberra. But there's lots of those silly little ideas to why things weren't done. So basically now, that's sort of the context of Canberra. I'm going to break now into the railways and how this all started. So basically, being part of the NSCAL group, I wanted to model my hometown station of Queanbeyan. However, members told me you can't do that because I'm going to do that model, so you have to pick something else. Why don't you do Canberra? I thought, yeah, but Canberra's really boring. Like, this is all there is. This is our station. It'll be really easy. I don't like the building, even though it is a modern building in architectural terms. And yeah, but anyway, I relented and said, okay, I'll build Canberra and it'll go with your future Queanbeyan, which incidentally hasn't been started yet, but you get that with model railways. So when I first started it, the first thing I came across was this building, which has Canberra on it. I thought, this is really odd. So to my surprise, Canberra has a long history of railways, and this is the 1914 station. This is one of 3 photographs I have of the station. And so we commenced building it, and another great source was the book up on the left-hand side called Canberra Railways and the Monero Districts. Also, this photo is another famous Canberran who's Williams James Milden Hall, who born 1891 to 62. He was actually a public servant and he had keen interest in photography. So he did a whole heap of photographs which are invaluable of Canberra's early development. Unfortunately, he lost his job when people thought it was unfair that a public servant was given the luxury of taking pictures, and of course it was outsourced to a commercial provider. But anyway, the first Canberra station was based on what we call the New South Wales Government Railways A4 station, which is the one down at the bottom. Although, because the railways employed tradesmen and builders of all the trades during the days, they quite often modified from the standard design to incorporate other things. So basically, from the limited number of photographs and being an architect by profession in a previous life, although I haven't done that now for 15 years, I basically drew up the station from the photographs. The other interesting modification for the A4 station in Canberra is normally the roof over the platform kicks up to give you more head height, but for some reason, maybe it was climatic considerations, the one in Canberra goes straight down at the same angle and gets quite low. You can see the edge of the roof is at basically a door head height. This will be the second of the photographs which appeared, including the pedestrian gate, and you'll notice the poplars in the background. Also in this picture to the left appeared the 1926 station, which is further beyond the 1914. So here is in styrene, N-scale 1:160, basically that end platform view, brass etches for the windows, And this was the design which would go on and win the N-Scale Convention Award model of the show. Down the bottom left is in my previous profession, I was a little bit ahead of my time, and I did 3D buildings and renderings of buildings. So that was one of our buildings for the local Radford College. Even though I have that skill, I still find it more therapeutic to building out of styrene and scratch building. So that's the way I've gone with this, and I find it quite relaxing. This is a later shot showing the 1914 station, the 1926 station, and I'm not a big fan of the 1942 extension, so it's just tucked on the end there, and I can remove it from the layout when I don't want to look at it. The 1926 building itself is quite nice, and a good shed on the left. I then came across this building, it's a historic photograph, and I always thought the station was on the right, the 1914 station, and the goods shed on the left, but it's actually looking from totally the opposite direction. So I thought, that's weird. They changed the window in the station from a double to a single. They didn't do that at all. And in fact, in the standard goods station, it did have two windows there. So this one's obviously been modified when it was built just to have the one. You can see a freight wagon on the goods shed, and also some passenger cars sitting in front of the 1914 station, and some very modern motor vehicles out to the right. So basically this is the recreation of the same photograph, although you can never match the optics exactly. And also I've got the much later, longer extended platform. But we've got passenger cars, and we have the freight car sitting at the goods station. So this is the 1926 station. With this one, there's the 1914 on the left. That's the third photograph I have of 1914. 1926 station is to the right. At this stage, it doesn't have the 1942 extension to the right-hand side. I was lucky with this one in that I had a bit of a head start in that there's a plan published in the Canberra's Engineering Heritage Book. So I had a head start with this one and didn't have to measure things. So I could start with that plan once I fixed the scale and the length of the building. So basically I drew up the plan for that, again, for the purposes of scratch building the building. I didn't realise at this stage, but there's this architectural style called Federation style or Canberra style. And it's prominent in the height. It doesn't come out from these drawings or the photographs. And there's a photograph from the front of it just prior to the Duke opening Canberra as New Parliament House in 1927. So this was finished in 1926. But it does pick up and looks very similar to the architecture when you model it as the Hyatt Hotel in Canberra, which is predominant style, and also the Hotel Kurrajong. And that was the name of the mountain I couldn't remember before. It's actually Mount Kurrajong, where Capitol Hill currently is. It's been renamed. So that's all out of styrene, all scratch built, a lot of fun. It also has the interior in case I want to go back sometime in the future and finish the interior off, but at the moment it's just all in white styrene. Here's looking up the road. You can see, again, 1914 station on the left, 1923 station, 1926 station in the middle, and the 1942 extension is that little roof addition at the end. I had no plans for the 1942 extension other than this newspaper article. And it's really interesting looking back at history. When you look at the newspaper articles, that describes exactly in dimensions, space, and from that one photograph, I could actually recreate like what the 1942 station would likely be like. It looks similar in architectural style on the front, but quite horrible on the back, and that's the bit I don't like. In this photo, you can also start seeing the emergence of the 1963 station, and that's it during construction. So at one time, the 1963, 1942, 1926, and 1914 stations existed all in a row. But at this stage, the 1914 was used as a staff office for railway staff working at the station. And here's just another view of all three in a row from the roadside. So you've got 1914, 1926. I have to improve my join a bit with the 1942 bit, but that's okay because most of the time it probably won't be there because I don't like it. And you can just see the emergence of the 1963 station on the right there. So it was really interesting, even researching the current station, that it was only ever planned to be a temporary station. And we'll get through this as we go through more of the planning of Canberra. So it was supposed to connect to by this time, there was originally planned a railway through to Yass to link us to the Sydney-Melbourne route. But in the meantime, they chartered in 1963 a new route through the Majura Valley. So hence this railway station was viewed as being temporary because they'd build a future one. And you can see on the diagram there, possible site for a new rail passenger terminal. And that basically aligns with the airport and through to the Majura Valley. Canberra's always been interesting in terms of railway stations, and our railway station is not at the city centre. And as we get into the planning a bit more when it returns later, you'll also see that there was also controversy about where the city centre was going to be. So, yeah, so that would make it hard to locate a railway station in the city centre when it hadn't been decided. And this is basically a photo from probably a week or two ago of where that model's currently at. The flags on the flagpole are basically a photograph. I basically stuck it in Word, did it back to front, reversed, mirror imaged it, then just folded the paper in half and glued it to the flagpole. And there you have flags. Sorry, it's not a high resolution shot. There's the flags as well. And this is a couple of weeks earlier before I'd done more painting on the station. You can see here the emergence of the railway in the cutting, and basically that's Griffin's route that would have gone through to a station called Southbourne. And basically I'm going to call this Griffin Station. Never existed, but I'm going to model that up anyway as to what potential could have been. And you can see the poplar trees in the background. Only one has totally been finished. And this is my design, which I borrowed from a local 1950s Canberra building, just to be the Griffin Station down in the cutting. And of course, I'm going to make it contemporary, so it needs a lift for disabled access. And interestingly enough, one of the stations at Russell, one of the reasons that that Canberra Railway wasn't never built into the city is they complained that passengers would have to traverse 35 feet of stairs down into the station, because of course back in that time they didn't have escalators. They did have lifts, but they couldn't move high volumes of people like an escalator can. So that was one of the reasons why Griffin's Railway was knocked on the head and delayed a bit longer. And that is from Friday night, actually. I just did the first facade, and the stairs have been in existence for some time. Just a bit of vision. This is a New South Wales 44 class. You can hear train dog jumping up and down on the floor in the background, which is the tapping noise. So that's a New South Wales Government Railways train from the 70s. Here's a separate one which I decided to put on a famous train in Australia called the Indian Pacific on, and imagine what it would be like if it pulled into Canberra at some time. And you know, I'd certainly ride it. So that was really interesting. That's a model that's built from a kit, painted, deckled, and similar with the carriages, they're all kits, deckled and painted, and they don't like the frog on that Eco 55 long point. Anyway, I'll have a look at that. I think there's some fixes for that. So when I published that on the web, my friend came back to me and said, Pat, that's not a silly idea. The Indian Pacific did actually come to Canberra for promotional tours in 1973 and one for later on. So the left photo is actually a picture that he took at Canberra Station, Indian Pacific, New South Wales Government Railways 44 class in reverse livery. And on the right is a later photo, again, to promote the Indian Pacific. This is actually taken at Queanbeyan Station, my local town, but it's en route to Canberra for promotions again. I'll just check how we're going for time. Heaps of time, good. So basically beyond the Canberra station, there was also a rail spur which basically went down into a suburb of Canberra called Kingston. Kingston also had the first power station in Canberra as well and had a spur line to deliver coal. So along that spur and branch developed a whole lot of industries. So the building in the centre there near the white rack is the engineer's office. Further back is a cargo office. The white building is the Carpenters and Metal Engineers office. In the foreground, in front of that building, I believe is the concrete pipe works. So basically everything in Canberra was constructed. Canberra was built at a very interesting time. As you can see a truck there in the foreground, which was the trucking technology at the time. And there's another truck I just noticed over to the right there near the steel rack as well. So Kingston now has sort of got medium density housing through it, but it was an industrial centre of the town, and at one stage regarded as a slum. Hence they wanted it gone. But basically everything in Canberra was fabricated or constructed in that suburb. So in terms of griffins and railways, he saw railways as central to cities, and he called them a form of communications. So part of his original design following the competition was actually to design linkages through the main Sydney-Melbourne line. So on the left-hand side, you can see the dark unbroken line has been the 1916 trial survey through to Yass, connecting Yass. And on the right is the later 1965 survey, which goes through the Majura Valley north of Canberra, and obviously supports that other picture of a future railway design. The image on the right, you remember the competition guidelines said we had to have a link to a seaport. So Jervis Bay and Huskisson was supposed to be Canberra's seaport, and this is the railway line surveyed through to there. Again, 1916, never built. In all seriousness, we'd never have Jervis Bay as our seaport because it's an environmentally significant area, and I don't think you'd ever get permission from the Greenies to develop it as a going seaport. So this was the latest scenario, and back when I put this in the presentation, it was still being considered by the New South Wales government. It's since been judged as unviable. Before Canberra, there was a railway line all the way down to Bombala in the bottom of the diagram. It's been closed for a number of years, but this looked at opening that line again and extending it from Bombala to the Port of Eden, which in my mind is a great solution. And then when I actually did some work down in Eden, the bottom yellow line is actually the line we took, which is an old forestry road, which avoids very steep, narrow mountain roadways. It's quite a good drive. And this is just another later diagram. So this is, there are various plans for what they call the arsenal, which is basically a munitions dump to support and defend the city. This one shows it north in a suburb called Dixon, but there were plans to put it south as well in Tuggeranong. So basically there's a lot of objections. So the railways were handed over to what was called the Commissioner of Commonwealth Railways to make adjudication on. So Route A, and you may not be able to see it on this map, but it's the northernmost one to the Market Centre, which was actually handed over to Defence, and the Market Centre and Civic Centre all become the town centre. So it was never realised. The Market Centre station was also the station that was rejected in the basis that it had 35 foot of stairs down to the station platform, which was not thought of at the time as being desirable, and hence that scheme, one of the major detractors to that scheme. The other thing was that it had to be tunnelled through Russell to get to, it's called the Parkway on Griffin's Plan, but it's now called Anzac Parade. So the Rail Commissioner came up with alternatives that were cheaper to build to get a railway into Civic. And basically they recognised Griffin's long-term ambitions for a railway. So their scheme is also offset from Griffin, so it could be built as a temporary railway, allowing the future one to be built. So this is the plan for the 1916 Parliamentary Works Committee, which is basically our committee which approves major expenditure on infrastructure. You can also see that the politicians and the bureaucrats were driving a railway line crossing Kings Avenue Bridge, which curls around there just below to the right of the Capitol. You also notice still at this early day the perseverance of the very geometrically shaped lake basins, which was later abandoned in 1963, or when they moved on with the lakes. And you can see here that the later plan of the lake system. And you can also see here the initial studies on the bottom left of the diagram of the causeway. So East Lake on the right, which was never constructed, was actually supposed to be 6 meters higher than the main lakes. And again, to control sediment and rubbish coming into the main lakes. Again, some more design studies, presumably by the engineers, to reduce the visual effect of the causeway on the Canberra skyline, and still using similar technology. So the diagram on the top left shows what we call as a clay liner, which is essential with any modern dam construction, just to make sure it's watertight. The diagrams on the bottom just basically show Griffin's idea. Griffin's idea of the railway through the city was that it wasn't to interrupt and there was to be no level crossings. So you got to remember there was no electric trains at this time. It was all still steam. So his idea was to dig the railways down 6 feet and use the excavated material to build a further 3-foot berm along all the railways, and that basically would allow bridges across the railway line, so there would be no level crossings. So again, revolutionary, ahead of his time. The view wouldn't be good, but then again, he designed it as a commuter rather than a scenic railway. So the railway was extended into Canberra, and this is the bridge completed in March of 1922. And presume the engineer, whoever designed it, standing on it. Again, a temporary bridge because it was built off the alignment of Griffin's Railway. And it was allowed to get construction materials into Canberra. Here's a picture from Mount Pleasant, and you can actually see the bridge still standing and the line going into Canberra. The building in the background is the Kingston Powerhouse and the industrial area of Kingston to the left of the powerhouse. This was the Civic Railway Station, built and actually not removed the platform. The track was removed 1935-36. The platform didn't actually get removed until the 60s. So it was there for a long time. And this is what happened to the bridge in September 1923. Basically, a flood came down. You'll notice in the earlier photos, the bents were built at an angle, or the frames that support the bridge at an angle to the water flow. Basically, a whole lot of debris built up and took the bridge out. At that time, the Parliamentary Works Committee decided not to rebuild the bridge until Canberra grew bigger. Just a view from another shot. This is a Milden Hall shot. Lovely photos. So basically here we have the temporary Canberra's railway lines in total, which I found in another book. Basically you have the line, Griffin's line, going to Central Station, which is now where Russell is, the defence facilities, and then City Station and Reed. You can see that it's offset from Griffin's, the temporary construction railway, and that's really good because that means I can model both. Also, we had what was called a narrow gauge railway, which I never knew about, but basically it transported bricks from the brickworks through to Old Parliament House into the City Hotel. And it was also extended through to the Kingston Powerhouse to exchange with the main standard gauge railway. After the bridge got washed out, they also extended it northwards across the middle of what is the current lake, but was then a river through Scott's Crossing. And the reason why railways are really important, particularly in a place like Canberra, we have very clayey soils. So as soon as you get any rain, the roads just turn into big bog holes. So rail was the most efficient and effective method of getting construction materials, both from around the state, but also once here around the city to the various areas of main efforts of construction. So there is one of our narrow gauge engines, and the bottom photo, I believe, is Scott's Crossing through the middle of what's now the lake, but at the back of that stage, the river. Kingston Powerhouse, there's currently a road there, and this shows the narrow gauge line and the cars pulled by the little, and even the narrow gauge steam train there at Kingston Powerhouse. And this was the state-of-the-art excavator back in the time, steam-powered excavator with a water cart behind it. So you could imagine the cost of Griffin's railways using this sort of technology at that time would have been quite cost prohibitive, and hence why he may not have got traction when there wasn't a lot of faith or belief that Canberra would ever be a success. And here's a picture showing the narrow gauge railway in front of our Provisional Parliament House. This is the Yarralumla Brickworks where the narrow gauge railway ran from. And this is a separate narrow gauge railway. This is actually horse-drawn, and it's actually just down from Kingston Powerhouse, which is the sand processing centre where they process sand for building. Another narrow gauge railway, again, it was just a construction railway used for building Cotter Dam. And this is a hand-pushed trolley system or narrow gauge railway system used for building the sewage works out at Western. Again, it wasn't connected to anything else. It was just used to move construction materials around efficiently. And this is Griffin's final plan. You've seen it before, but you'll notice that the market centre is across there to the right, which ended up and is currently to this day the military officers or defence officers in Canberra. But other than that, largely the configuration is the same. The lakes never took up those pure geometric forms of the centre basin, east and west basin. In terms of the model, this is my proposal to build it all the way to Russell. So we have Canberra Station down at the left. I plan to build the causeway, East Lake, but also the temporary construction line in front of it, which should be pretty dramatic. And then also the industrial spurs through to Kingston. And then it'll loop back and, yeah, just come back. So that's sort of it in a nutshell. I'm just open to any questions now.
Okay, so that was quite interesting. The background of the Canberra Railway. I remember watching this when we did it on NMRAx, and so we thought, well, things we recorded it once, we'd use that playback. But we've got Pat here to answer any questions anyone has. So I'm having a little look in the chat here, and there doesn't seem to be anything at the moment, but it usually takes off after the clinic's finished, and it's just wrapping up now. So we'll just see what pops up there. I'll go over to Facebook and have a look. And what have we got in Facebook? No, there's nothing in Facebook. So looks like it could be easy on the questions, Pat, but that doesn't matter because I believe we've got a couple of other things that we can look at, which will probably generate some chat, I'd say.
Yeah, sure. So I'm at Sydney N, so we may as well just do some footage of Sydney N, and we've got Ian just to explain the layout they've got up here. They've just basically moved from Peakhurst through to Rockdale to a new facility, and the club layout's under construction. So
cool.
I'll just swap around and I'll throw to Ian.
Yep, off to you.
Hey, Ian.
Hi, how you going?
Want to tell us a bit about the club layout here at Sydney N?
Best way to describe it is to think of a wagon wheel with 3 spokes. There's the central hub, which will be here on the second level, which hasn't been built yet. One spoke goes from roughly around Spokane, let's say, north Calgary, which is the existing piece that you can see here, you'll see. Another leg will go west towards Seattle through central Washington State, which will be the centre level. A third level, which will be about here, would go the opposite direction towards Missoula, so northern Idaho, Montana type scenery is what you'd expect to see. We will, each of the levels are hooked together through 3 spirals. So we can relocate trains behind the setup yards, basically, so you can reset them for an operating session to run in and out from the central hub down on the 3. And obviously you can go around the layout 3 different directions.
Excellent. All right, thanks. Yeah, so we'll just have a quick squiz around. So this is it as we speak. This is the Canadian section. Yeah, so the guys, how long have you been here now, Ian? Is it 2 years since moved from Peakhurst? Yeah. So they've made pretty good progress in 2 years. So basically Well, the aim was to get the main loop established first and then to work back through and add the industries at a later date. Some of the industries are being added in, so you can see some of the sidings being set up, still needing some paint, but yeah, they're getting there with it.
Nominal length of the layout is 42 square miles.
42 square miles. And how long does that take to get around, or does that depend who's driving? Huh.
It takes about 25 minutes to do the current level.
Yeah, and that's their spiral. So, like speed, we could probably sit in there and they can probably broadcast from inside the spiral as well. But we've got this little curvy bit through this one. And I'll just take you through to some of their exhibition layouts. So this is a two-story building that they have in Rockdale. This is the Canadian layout. Moose Jaw, slowly being retired. If you have a look at my Facebook page, you'll see a fair bit of footage on here of Canadian trains running. And of course, the mandatory Canadian flag. How are we going for time there, Marty?
We're doing well. We've got about another 10 minutes to go.
Okay. And any start on questions yet?
I'll have a little look back over in the chat. There are no questions there, just a couple of comments. David North said, excellent presentation, Pat, well done. And Jeff Chatwin said he's always been interested in the Yass-Canberra link. So,
yeah, the one that was never built.
And I don't think there's anything on Facebook. I'll just have a look over there, but my Facebook's been doing...
Same sort of thing over in Facebook. Andy Ambrose has put in there, Pat has explained everything so well. He has answered all the questions as he went along. So yes, we often find that well put together clinics seem to self-answer the questions. So
Yeah,
great clinic, Pat.
Andy, yeah, catch up with him quite a bit. So yeah, say good day to him. This is just a Victorian-based layout again. It's called Widgery, and yeah, they used this one on exhibition.
It's a quality Victorian railway.
Ah.
The rolling hills of Bendigo by the looks of it, or Bonnie Doon.
Yeah, so it's quite nice. So it's quite a good facility they got here. 2 stories, leafy Sydney. So yeah, they've done quite well. We'd like to have this in Canberra, but not enough room in the car to take it back, unfortunately.
Yes, it is a nice building to have as a club room. You've got plenty of room to build stuff, and by the looks of those layouts, they got plenty of running opportunity.
Yeah, there's no shortage. While they're in construction, they do mostly work days and just have one running day a month. And I think they also do a work day on Wednesdays, just to construct it.
Okay.
Yeah.
We've got one question that's come in here on the YouTube feed from Crafty Method, and he's over in Albany in Western Australia. So he's probably not been over to Canberra or the likes, but anyway, we'll find out. He was saying, how deep were the lakes? Were they used for much shipping?
No shipping at all. They're purely recreational and aesthetic. Walter Burley Griffin thought that Canberra was in the desert, so they thought they should have some water bodies. And then it actually creates really bad problems with fog in winter, but anyway, they're pretty good.
Yep.
So purely recreational.
Okay, how deep are they? They're not that deep, are they?
No. The sailing basin, my 7-metre mast won't touch the bottom, so it's deeper than 7 metres. The East Basin is probably the shallowest, where they do rowing shells, just practice. It's not even deep enough for proper competition regatta racing over there.
Okay.
This is one that El Presidente will probably like. It's a Scottish-based exhibition layout.
Oh, yeah, that'll definitely get Gordy's interest. You'll probably be watching. He won't be up at the moment, I don't think, at 4 in the afternoon. Is that
Fair
right,
enough.
Brad? You'll still be pushing Zeds out, I think, and we must let everyone know as well that he has a new addition to the family. So he's got young Magnus now. So he's probably had a few sleepless nights.
Okay, so a bit more grumpy than usual. All right. Well, if that's all, that's just about it for Sydney N and around here. So I hope that's added some extra content for your viewers.
Yep, beautiful. It was a good little look around another layout around in the Sydney area, and when the N-Scale convention gets down there one day, hopefully I'll be able to drop in and have a bit of a look. But that was great.
No worries. Okay.
So,
hopefully the event runs next year in Melbourne. So
yeah. So Brad, there's nothing on Facebook.
No, you've answered everything pretty well, Pat.
Okay, fantastic, guys. Thanks, and you're doing a great job. Keep it up.
Not a problem. Take it easy, Pat. Bye.
Bye.
So, Martin, how about we, instead of heading to some ads, we jump over and see what the guys at Silicon Valley are doing? I know the Aussies are still over there driving some trains.
I reckon that's a good idea. I reckon we should go over and have a little look. And I noticed Jerry Hopkins was driving a train before.
Yeah, so I might switch over. I'll see if I can get some sound up this time, and we'll see what they're up to.
Okay.
Yeah.
We're almost there.
So, how's that? Is that up and...
That's up and going, and we've got some audio going out, so let's have a listen in.
You're clear. You can stop now. I'm actually going to pull out the mega drawer and replace some of the cars. So you've never seen this. We have a big drawer here.
So that's Justin, I think, on 429.
Oh, okay.
That pulls out.
Oh, yeah.
Yeah, I believe it is. So we've got Jerry up there on 6504, Merv from up in Queensland on 4403, and yes, I believe it is Justin on 4429.
So is that on?
Don't know who's on 7603.
It's on motors. There is kind of what looks like almost like a car alternator somewhere down under here.
6504.
So this is just another sideline event that the AR convention was having. It was a bit of a sign-up, a bit of an intro into remote ops, so I'm sure the guys that signed up had a great time having a go of it. I saw Duncan over there before.
Yes, yeah, I saw Duncan. He was a high roll, and when I went through there, but there you go. So there's a couple of Australians, probably from New South Wales and Queensland, over running trains on a layout in the Bay Area in San Jose, California.
Okay, Martin, how about we cut back to the studio, and we might even venture over and see what's going on in the lobby. So,
well, we can go and have a Captain Cook at that and see if there's anyone there.
I'll duck over, and I've just got to get signed up here. So, let's see.
Gonna come over here.
We've got a few guys kicking around here in the room. It looks like we've
There he is.
Darren Lee and Craig Mackey sitting here in the lobby themselves, and I see we've got a couple of people over in the rail fanning over in America. And I also see there's a few guys over talking about some MQ trains. So if anyone wants to jump in here, definitely I'll put the links into the chats very shortly.
So when you go over there, all you have to do is whatever group you want to join in. So there's the rail fanning one there. Jordan's got he's out and about at the moment in Cincinnati doing some rail fanning. And if you click that group, you'll be able to watch what he's looking at, and he'll tell you where he is and what he's doing. And over in the MQ trains, you've got You've
Yeah,
got the
that's
gurus telling you how to
just
do all your
everyone's
occupancy
feeds are different.
detection and the like.
delay.
So hop in there, have a bit of a chat, and we'll be back, I guess, in a little bit, Brad, with
our next clinic. Yeah.
with our next clinic. Okay, welcome back for our next clinic presenter. We've got a long-term member of the NMRA. He's been a member for 37 years, and he's served on numerous committees and positions on the board. As regional editor of the regional magazine for 10 years. For the past 18 years, he's been looking after the AP regional chair position. Is basically his first job. He comes from South Wales, so he's a good guy. And his first job was British Rail, Western Region, as an electrician. When he started, it was all steam, and when he left, it was all diesel. And it wasn't his fault, so don't blame Jerry for it. And so that shows his love of steam locos, because he worked around them obviously when he was younger. And his electronics background has been very handy in keeping up with control systems and layouts in locos. The teacher asked the 7-year-old what he wanted when he grew up. Without a moment's hesitation, he replied, "An engine driver." Well, I never got to become one, but my love of trains has been with me for most of my life. So here's a little story from our next presenter, which is Jerry Hopkins, MMR. Over to you, Jerry.
Well, welcome to a bit of my layout. Shows operation. I don't stand there explaining way builds step by step. That takes too long. But there are plenty of trains running, showing people switching with explanations as you go.
Okay, so I guess we'll run that video. Load up the Super 8 projector and hit the go button.
Welcome to my layout, the Great Northern Down Under. We're just starting an operating session. There'll be people switching in the different locations, the towns, and the yard master will be assembling a train to go to one of the towns. One train going into Havre. While not prototypical, I have taken the names of the towns along the route just to give the feel. 90% of Australians wouldn't have been there anyway, so they wouldn't say I've done it wrong. This is the town of Shelby, the main marshalling yard, classification yard on the layout. Trains come from staging into the yard, drop cars, pick cars up and go off around the layout to the next staging point. We use car cards and waybills because from a paper point of view it's easier than doing switch lists before each session. I've done enough paperwork in my life that I don't want to do any more in my hobby. The system runs with Easy DCC from CVP. The command station is just under the yard where all locos are assembled, any consists are made, and there's a high and low power district. Those are the 2 meters below the command station. The 2 moving coil meters on the right are for the auxiliary power line. A through train, plenty of cars on this one. Some names you might recognise. We have an 080 switching the yard. Starting the 2% grade past Essex. Past the Essex paper mill. And the moose are having a little outing underneath, eating the wet vegetation. The yard is being switched. There's a train of 5 cars in, and the Spencer is doing the switching today. The Z6 Challenger has stopped at Great Falls North to take on water after the climb up the hill. On this layout it's normally a count of 3 for each car on the train, so it does take a while the longer the train. Some people forget, but then they get into trouble with the cattle prod. Have a couple of workers playing chess on the dock waiting for a train. And because of all the rain they've had in the spring, flowers are starting to bloom. We even have a squirrel in the tree. Starting to coast down the 2% grade. A couple of rail fans watching the train go by. A very famous Australian prospector, Don and his burrows. That's for the Australians. At a number of the points around the layout, where there's a lot of switching done, there's a slide out draw. It's out the way normally, so that people can go past. But it's there. We have one under the main yard at Shelby. As mentioned earlier, we have some slide out drawers underneath the layout for putting the cards on when you are switching and you need to sort the cards out. This is the one underneath Essex, and as long as you don't disturb the deer on top of the hill, everything is okay. And we can push it back in out the way when we finish switching. We have a short freight coming out of St. Paul on its way through.
The train that had been switching at Havre is on its way round and will end up in Shelby, where the cars will then be placed on trains that go through to either St Paul or Seattle, one way or the other.
He's not going. Come up, he's coming up.
The Alcos have got dynamics brakes running, coming down past the Moccasin grain silo. Little bit of extra dynamic brakes at the bottom of the hill. Coming down past the work train. At Shelby, the yard master's using the table for the car cards. Car cards are fairly basic, as you can see. There's car going to St Paul to a covered hopper, so that's being switched to another track. We have one for local switching here, which is a green boxcar, 40-foot boxcar. The Alco's coming into the yard now. Speed limit in the yard is 10 mile an hour, and that's what he's doing. Spencer's taken a steam local up to Great Falls, and he's going to be switching here. At Great Falls, to help the operator, the turnouts are operated by slide switch, which are mounted near the edge of the layout, where there are multiple turnouts and switches. They're coloured. There's a coloured drum on the ground, and if we come down here, there's a yellow drum on the ground there. There's a red one in the back, which is the one that's just been changed. The switch has got a red marker on the top of the switch. One day, in the dim and distant future, we may have servos operating here, so it's just a case of pushing the buttons. The cards show us that they're coming into the team track, and they've been left there, and the train will now pick up the stock car he's pulled out and take it away with him. So again, change the turnouts. There are rods underneath the scenery, so it makes it nice and easy. If I put servos in, they'll replace the switches at the front of the panel. This is a very, very old, abused steam loco. Driven by an experienced driver. The paper mill at Essex, you can hear the machinery running on the inside, and it's an interesting place. The control panel for the paper mill doesn't use red and green like most conventional panels. It uses red and white. Much easier for colourblind people to see, because reds and greens look the same. So this one is done for those who unfortunately have a little bit of colour blindness. The train on its way from Billings to Habra. The yardmaster is still busy making up trains the cars that have been brought in recently. They've come from towns around the division, and they're being made up to go to Seattle, St. Paul or Billings, the three big towns which are not on the layout. The train from Billings to Havre should be going through on the main line. The throttle is set for speed 20, which is 20 mile an hour. And our speed trap says 18.8 because he's just slowed it down a bit. So we were close. These cars will be switched out and passed over to Medusa Cement, which is at the end of the yard. So the local switcher will run out and collect the trains. Always something to do on the Great Northern. The switcher coming out of the yard. The loco that normally works as a helper for long trains on the hill is helping with the switching. It's taking two cars, it's pulled two cars out and it's now putting two cars back in. You hear a big freight going through on the main line. Normally we have 6 operators, today we've got 3, and it makes it nice and quiet and smooth.
bugger it up for you to...
Well, I've got to get past the establishment.
Get to Great Falls North. They've come in from different places. These are the cars being looked for in the yard, and they'll be pulled ready to go to Great Falls. We have one 40-foot box car with a normal door and two 40-foot box cars with double doors. That's the XA classification. Switching at Great Falls North. It's all tail switching at Great Falls North, so no run around required. Picking up box cars from JI Case factory and dropping empty ones in ready for loading. The waybill tells us where the car has got to be placed. In real life, the conductor would carry this, or it would be attached to the side of the car. Because our eyes are not that good, we can't see the small print when it's attached to a car, so we make the car card. And this is a double door box car. It's red and the number is Great Northern 38144, which is industries and towns. There's also a shelf for the waybills and car cars to sit on while that area is being serviced. Once it's serviced, those car cards are placed in the appropriate boxes. And again, you can see green lights with two red at the end, because the engine on the right hand side, this side of the two trees, is on the interchange with the Chicago, Burlington and Quincy, and these are wagons being returned and will be going into Shelby Yard. At all switching locations, there's always somewhere to put the throttle, and you can see the throttle holder. These are slightly converted electronic rodent retainers. They're the industries. You don't know where the industries are, so there's always a diagram above each section showing you where all the switching points are and all the industry spots. This is the signal protecting the main line and the turnout into the paper mill. If we press the button to change the turnout, you see it goes red. Immediately the signal goes red and the turnout throws. Coming back the other way, we shall press the button again and you'll see it go to green to show the direction you have chosen, but the light will stay red until the turnout has gone all over in the correct direction, and then it will give you a clear signal. There we go. It's over there. Great Falls is the highest point on the layout, and switch stands, tall switch stands, show that these are operated by slide switches, so people don't have to reach over the layout, especially those who are vertically challenged. We've mounted the slide switches at the front edge of the layout, and as you can see, each one has a colour: white, red and yellow, and the corresponding turnouts have oil cans near them: yellow, white and red. So when we slide switch, the corresponding turnout operates. The gantry is showing 2 lights for the main line and the passing loop, and the far signal, which is slightly lower, is the branch line to Billings. At the moment the track is set for Billings, so we press the button, the light goes to red, and as the turnout throws, now we have a green light for the main line. In Augusta we have 2 turnouts, which will give us 3 tracks. We select the track that we want. We want to bring the train out that's parked in there. We know there's a train there because we have a red light. That one's okay. We want to come through there, so we change that to green. These are done by servos and the Tam Valley singlet boards. When a train goes in and gets to the end of the track, we get the red light come on as just shown. This is the track plan for the staging. There are 3 tracks for Seattle, 3 tracks for St. Paul, but I do have a through track if I want to run the Empire Builder or a long train just for open days, just for trains running round and round. At the Seattle end there are 3 turnouts, but you don't have to stick your head in or periscope or magnifying glass to see which way the turnouts are lined up. We select accessory route 55 on our throttle and press the button, and they change, and we have track straight through. I can't remember the turnout numbers, they are marked, but all I need are the numbers on the end of the track, and 55's the one through the middle. Selected track 51, which is the closest track to me, and it has a green light in the track, so you can visually see that it's set up. The other one's got a slight green tinge because of sunlight coming through the window, but each track has an indication to show you the end of our little trip around the Great Falls subdivision. As a switcher pulls a cut of cars in the yard, and
Oh, we got to give him some action shots, haven't we? Yeah.
Without talking. We got to do it quietly.
All board?
Thanks, Jerry.
Which track are you going on, Jerry?
Go through.
Back on Torrego now, so it's photo in the dark just about. And we set it on about a 15-second exposure, and we had a torch and we just paints the object. So we wanted light and it wouldn't be dark except the object. just see my son coming up to do Singapore, he's my filmmaker in Canada. He's coming up to make a demo of my layout. Because he wants you to do an image photography. For your own 4K ultra high definition professional video.
Oh, there we go. That's a good start. If I remember to push the mute button, and then we'll get Jerry to push the mute button as well. Okay, that was a good video, and there's been quite a few comments in the chat. I noticed that Jerry answered a lot of the comments that are actually in the YouTube chat, but I noticed a couple over in Facebook. I did a couple of refreshes and restarted Facebook, and I got chat for a little while. So there's a couple of questions, and obviously there's a lot of comments on how nice the layout is. Greg's there. Greg, remember Greg Harper, Brad? I believe he won a photo contest on another website, another podcast.
I believe he did.
Back. Yeah. Anyway, well, that's another subject altogether. But going on, there's Darren Daz Lee up in the hinterland here on the Gold Coast. He wants to know the system you use to generate traffic flow with your car card system.
You don't actually generate it. You have a bunch of cars parked with waybills, and there are 4 sides to a waybill, and you turn them over. Not every car gets moved at every operating session. It may take 3 or 4 sessions before a car is moved, depending how clever your operators are. And as we only do it once a month, it takes a while to learn the layout. But a car has to go from A to B. So it goes from an industry to another industry offline. And out of the 4 sides, only one of them is on the layout. The other 3 are at different staging yards. So that keeps the cars moving around.
Okay.
Not really scientific, but there you go.
And he also had another question about the signaling system. Is it automatic or only indicates turnout position? And Greg's put a comment there. It says, unless it's changed, it used to be turnout position.
Well, yeah, turnout position. That is one worked off a sensor. I do have about 25 detector boards, which I have to wire in and do it a bit more elaborate. But I've been waiting 8 years to do that and haven't got round to it yet.
Okay, well, that was all the questions that were over in Facebook, and you've answered most of them in the chat. There was some comments on YouTube about the sound, and it was good to hear a layout where the sound of the effects and the logos were balanced. And they wanted to know how you did that.
Just listen, just stand near it for about 5 minutes, and if it gets on your nerves, it's too loud. You've got to turn them down.
Okay.
They've got to be subtle in the background, the building sounds, any on the layout sounds, and the locos are 10 foot away. You shouldn't be able to hear them.
Okay, well, I think that just about gets all the questions. Have I missed anything there, you reckon, Brad? Or?
No, I don't think so. Once again, I love Jerry's videos. It's always great to sit back and watch them.
Well, I can always attest that it's a great layout to go to. If Jerry's ever got an operating session going, jump in there, because it's a whole lot of fun, especially if you've never driven trains and had to use the brakes to stop things.
They're the people you don't get into cars with.
Okay, well, thanks a million for that, Jerry. That was great, and we shall catch up with you soon.
We should catch up with you very shortly. Martin, just before we go, you just mentioned before that Greg won a photo competition. How about you close out this clinic with that famous pose again?
I don't even know. I'll have to hit the camera. Hang on, I can't see, Mike. There we go.
Near enough. Now just...
And look, I can even reach over and put the OptiVisor on to give you the full effect.
Perfect. Thank you, guys. Thanks, Jerry, for the clinic. We'll be back shortly with the next one.
Thank you.
Okay, we're back here at the AR convention, virtual convention for 2021. That was a great clinic by Jerry, and we've got Chris Lord coming up now with upgrading an ARM 38 class. So the bio here is quite extensive, but I'll just pick a few points out. And Chris has been a lifetime modeler. He's introduced to model trains at a few days old by his father, and he's been a continuous interest ever since. So he caught the disease early. He does New South Wales, obviously, by the selection, and he's a bit like myself. He's a rubber scaler. He bounces from one scale to the other. So, being as I've got a dabble of N, mainly HO and some ON30, and we used to have some G gauge as well, but I got told it had to be curtailed. But anyway, like many modelers, he also finds it hard to pass the prototype railway without stopping and looking, plus taking photos of it. So he's an avid prototype modeler. This clinic's is recorded, so I think Brad's got the old VCR out, the old VHS VCR, and he's rewound the tape and he's put it in, and I believe we can hit play on that button.
Thank you for joining this presentation of the NMRA Virtual Convention. This is an overview of the ARM C38 class model. The original presentation was filmed and 90% of the footage was lost when a device failed. A good reminder to back up everything, but unfortunately that didn't occur at the time of the failure. So this presentation has been produced using parts that were available that were recoverable, and some new parts and a lot of still images which were originally taken when the presentation was made. So hopefully it will be able to be understood. Apologies for any of the inconsistencies in the video. Welcome to a quick overview of the ARM C38 class locomotive. The C38 class locomotives were built by the New South Wales Government Railways. 5 streamlined versions were made. This model here represents the remainder of the class of 30 in a non-streamlined form. As we rotate the model around, we can see some of the details are quite crisply represented. It has nice motion on the model, plastic moulded parts, some metal handrail parts. Background on the front here, we have the Westinghouse air compressor, headlight moulded to the smoke box marker lights, metal handrails that run the full length of the model, a fairly accurately represented Delta truck at the rear, and a reasonably well detailed cab interior for a basic model. Plastic handrails attached at the rear. Spin round to the driver's side, we can see the power reverser is represented, the steam generator or dynamo on the top. Down here we have the representation of the lubricators, steam cylinders and the Walsh Arts valve gear. On the front of the pilot we have plastic mouldings for the shunters poles, steps, a hook representation, 2 air hoses, moulded buffers with metal heads. Alright, a few bits on the model which we might like to change later on, or while you're doing some extra detailing to it. The handrail on the 38 class on the driver's side is actually the regulator. So the regulator comes from the cab, runs down the handrail here to a quadrant, and then follows along to the actual regulator valve actuator, which is mounted here, which then follows across into the smoke box to the steam valve. Now the model is represented with a nice shiny handrail that doesn't actually go to the regulator mounting point. There's a bit of a sort of an indentation on the boiler, sort of portraying where it should be. So that's one item that can be easily modified by cutting the handrail here, drilling this little hole out and mounting an actual throttle valve in that position. There are cast pieces in brass for that, made by Aussie Detailing Parts, and I'll show you a couple of those later on. Up here, the steam generator or dynamo. Whilst it's a basic representation and you could get away with it by adding maybe a little steam pipe out the top or something like that, there are some nicer cast versions available. So there are two companies that I've seen recently that have them, and that's Karobi Models and Aussie Detailing Parts. One is a lost wax casting in brass, and one is a pewter casting. The next area we can sort of think about up here are the safety valves. 38 has two main safety valves and a third relief valve up in here. Now, whilst these are quite good on the model, several of the models I've come across, these have been sort of not quite right. So the moulding process must be a little bit random. My own particular model, they were actually quite bad to the point where they were sort of not even looking like a safety valve. They were sort of mushroomed. So maybe in the assembly process they've been squashed or whatnot and they've just been fitted. So you can replace these. I found a manufacturer called CalScale, and they produce some nice brass versions of these. We'll just come back a bit here and we'll spin the model around and we'll have a look at the other side. Apologies for the dog. Now right here is one of the most glaring things missing on the model. There is no whistle. A 38 class has a nice big whistle mounted right here on the top of the smoke box, and I'll include a photo of that, of a prototype model. There are several manufacturers that do these, including Aussie Detail Parts and Karobi Models. They can be easily placed up on here, and a very good addition to the model. Another item on the model which we may like to change is the expansion link. So here we can see the link in position on the model, and the way the rod connects down to here, and then the actuating angles through to the valve chest up here, it just doesn't look right. It's quite a nice representation of an item here as far as the detail goes, the fineness of the actual links. They all sort of move around quite freely. However, the link just doesn't look like it's positioned right. Visually, when you see the model running, it just doesn't look right. So this isn't quite an easy one to do, to actually modify, and I'll show you some photographs of what a real one looks like in a moment. However, there's a little pin here which can be eased out from the plastic mounting here, and it allows you to then adjust the position of. A very quick and easy way is to pull it out, lift it above the actual pinhole, which is drilled in the centre, and allow it to sit back down on the next section along, which will then give the alignment visually a much better angles. The next step further on from that is actually soldering up the original hole and just below it and re-drilling a new pinhole, and then using a Dremel with a motor or a moto tool, cut out the section above the original hole so you have a clear section in the quadrant. It's just one of those things that, to my mind, makes the model look visually much better, and you'll see that on my own model when it's running on those videos. Now, for some people, this modification may be a little bit too much above where they think they can go. And one way I've discovered of actually making it so it's really not noticeable is painting all the valve gear to a darker colour. You'll have a look at most of the photographs of the 38s in service in their later life, and the valve gear had become basically a grungy black colour, or sort of a stained oily colour. And just giving this whole area a coat of a darker colour, painting the rods out into a darker colour and the motion here, hides visually these inaccuracies that we can see here in this link rod, where it looks like it's sort of running down into the track instead of aligning to the cylinder plane. So that is one way we can actually hide the detail here, but visually to the mind, it tricks the mind into thinking everything is right in this location. Disassembling your 38 class, you'll find a pair of screws, one here and one down here on the rear of the model. On the front of the model you'll find a screw in here which mounts this front bogie assembly. Past that there is a screw mounted down in here. Get the camera around and we can see that. A little bit down through there. So that's easily accessible once this front bogie is removed by that screw through there. And then the chassis will easily wiggle out from the model. If you want a bit more room at the back here, you can easily remove the rear delta truck by removing this screw here, and that will give you plenty of access room. You won't have to worry about getting the screwdriver past the detailed parts at the back of the model here. Now, doing this on camera at funny angle around the camera is a little bit difficult, however it's still quite manageable. And now we can see this other screw right in here. That's the last one you'll need to be able to remove the body from the chassis section. So we'll just undo that, try and hold the screwdriver at the same time. So that's that screw now loose. That's dropped out. Grab a pair of tweezers and we'll grab those rear screws out so we don't lose them. As we turn the model upside down, and a little bit of a wiggle, and we're now in pieces. So we have the chassis section of the model. We can see the European parts here on the motor. Quite easy for you to remove those. People without soldering skills just nip them off here and here, or if you'd like, unsolder them, take the piece away. This is here purely for AM interference, not required here in Australia, and if you're going DCC you are much better having that item off it, because your DCC decoder is recommended by almost every decoder manufacturer to remove those suppression devices. Okay, here we can see the weight now located inside the boiler. And this is it down here, and we can see the space provided above the boiler, above the weight. Isn't that great? You could fit a little cube speaker in there, a little flat plain one, but it's really just enough space to run a decoder down inside, as you can see there. Now, if your smoke box front is a little bit tight, this is where you run a little bit of a drift through, and I like to use these bits of plastruct. Just cut to a length where you can sit it down there, it won't damage anything, and give it a little bit of a tap and the front will come straight off, allowing you to then slide this weight out of the front of the model. Alright, here we can see the handrail just popped out and it will sort of swing aside on the driver's side. The handrail on the fireman's side tends to swing back inwards. This is due to the way it's actually mounted up here. However, you can pull it slightly forward. Can pull it slightly forward here, and it will give plenty of clearance for when the fronts of the smoke box comes off. Alright, just before we take the weight out, there is a screw here, which I forgot to mention earlier, that actually locates the weight solidly to the model. So once you remove that screw, the weight will become loose. Right, after a little bit of a tap, we can just push the smoke box front off from the inside there. You can see it coming off. Very small amount of glue to hold these on, just usually around this very top section. And here we see the weight slid out. Now, for those wondering about putting a decoder in above the weight, if you are not putting sound or something like that in, they've very thoughtfully added a section of 3M, we'll get that the right way around, tape above here. Doesn't quite cover the whole area, but at least there is some insulation there. Okay, here we see the inside of the boiler, so we can look down there, and there is actually plenty of space on the inside of it there. Zoom out a bit, maybe. Yeah, so there's plenty of space down in there. Once the chassis goes back in, a bit of that is taken up. I actually might just sit the chassis back in there to give you an idea of what available space is. The machined weight, after it's been to the machine shop, taken a large amount off it, you can actually just see the moulding line in the weight there. So just take it down to just above that, and then we swing it round, and we can see into the front of the model there. This is just sat in there, that's not screwed in, not actually physically fully mounted. But you can see now the position, the weight, and the good size speaker takes up just under the chimney. The big advantage of this is the sound comes out of the right spot of the model, not out of the tender, out of the chimney where the chuff should come out. Whistle as well, 38 class has a whistle mounted right next to the chimney, so your whistle sound will also be coming from exactly the right spot. Another advantage is the weight is probably too heavy for the front of the model. Now, it balances more weight to the front of the model than spreading it evenly over the length of the driving wheels of the model. So taking a little bit out of this weight is not an issue for the model. It will still pull 17, 18 cars on your layout. Okay, so let's turn our attention back to some of the detailing on the model. Items like the headlight here are made of plastic. The dart on the front with the wheel, also a moulded piece. The marker lights, moulded. The little handle for the front of the smoke box door, moulded as well. We can see the moulded detail here. Doesn't really represent the actual item. Same up here. This is the dynamo. And then we've got other bits like these parts here, which are very well detailed. But some people may like to change those out for cast items that are available as well. So what I'll do, I'll put some photos up now of some of the items on the model that you may like to change, and these will be prototype photos. So we'll see a prototype photo of the side of the locomotive here with the dynamo. So the dynamo sits up on the top of the boiler here. Steam fed, powers the electrics of the locomotive. So headlights, marker lights, in the modern times powers a battery to run the ice equipment that they need. So it's a vital part of the locomotive, and it'd be nice to have that modelled nicely on the model. And as I said before, there are parts available for that item. Further up on the boiler, we have that actuator for the throttle. So as you can see in the photograph here, it is quite a noticeable item on the model. So without that represented, the model seems to be lacking something, and that's something we can easily replace with a detailed part. On the other side of the model, Turning it round to the other side, we can see items like the whistle. It's so glaringly obvious that the whistle is missing. As you can see in this prototype photo, a missing whistle? Oh, it's wondering what the manufacturer is thinking leaving that off. So hopefully when they do a second run of the model, they'll put a whistle on there. So the handrails on the model, they are bright and shiny, made out of a nice metal, very shiny. Now, photographic evidence would suggest maybe the first green locomotive did have shiny handrails, polished. And maybe one or two locomotives that for a special service may have had the handrails polished. But generally all the photographs show the handrails actually painted either the body colour or a black colour. Whether the black was just dirt or it was actually painted black is a bit hard to tell. Some of the photographs being black and white, the contrast is hard to tell, but the early colour photos definitely show mostly coloured handrails. So the length of the body, or the boiler length, generally the colour of the boiler. And in some cases they were definitely black. So that's something we can easily change. A fine paintbrush, and you can touch those up very easily. So looking at the prototype photos, just these couple of extra ones, it'll be easy for you to see the variances here on a few different prototype locomotives. Okay, on to removing the electronic parts that aren't needed on this model. The capacitor here is not needed if you're going DCC. And as simple as that, touch of the soldering iron on both the tabs and away it comes. There it is there. Now on to fitting the decoder. Very basic on this one. It's a ESU micro, 8-pin connector, a little tether. Pin number 1 is in the lower corner here. Pin number 1 on the 8-pin connectors up here. And we align those two and hopefully we'll just push in. So now we have the decoder mounted. It's time to connect the 2 brown wires to the speaker. The purple wire is an auxiliary, which won't be needed on this particular install. Modification to the base plate involves removing this section of the base plate. 2 screws, one here, and we should be able to remove this section of the base plate to allow access to do the modification. This is the base plate removed. That now gives us access to the pickup strip and plate, which also retains the driving wheels. As we see this plate then eased out of position. I'll tilt it down carefully. This section right here is what we'll pay attention to. That surface there holds the axle bearings, or horn box in reality, up in position. Now that holds it fully up position, no float whatsoever. So with this base plate off, there's a small amount of float. We don't want to give it too much extra float because this is also the driven geared driven axle. But having a little bit of extra downward movement helps massively with that pickup issue. I've just made a little mark there. That is the center line of the axle. Now this has also got a phosphor bronze plate that runs along the side of the plastic retainer. So using the half round file, you can just see that there, we will take a very small amount out here to create a slight curve in that section there, which the bearing can sit down into. So we're talking like 0.0 something of a millimetre extra clearance here, not millimetres of clearance. The very small amount has been taken out here. It's only a small amount, and it's all it needs is just a tiny bit to allow the bearing, which is round in its own surface, to drop down a little bit. Allows the axle to have a little bit of movement, and the centre axle will then sit on the rail head all the time, and if there is any downward undulations, it will also track down onto that. While you've got the base plate off, it's also worth checking that these phosphor-bronze wiper pickups actually do contact the back of the wheels at the end of their travel. So the wheels have quite a bit of left and right travel, and in some cases, if these phosphor-bronze wipers aren't enough tensioned out to the wheel, as they go around a corner, the action of the wheel moving across will make the pickup come out of contact with the wheel. Less pickups equals less electrical reliability. As delivered with the model, this front bogie mount has absolutely no side control. So it's just a floppy arrangement, and it can just move backwards and forwards. Now what side control does is reduce the overhang on a curve of this front section of the locomotive and assist guiding the actual driving wheels into a corner or through a set of points. In a real locomotive, the front bogie has quite a bit of springing in it, in this left and right movement, and as the bogie goes into a corner, it acts against the springs and helps to guide the locomotive driving wheels into the corner. Without this on the model, we end up with a large amount of overhang slop going around a corner. So the keen modelers may like to do some modelling here and start to modify this mount. One quick and easy way of giving some small amount of side control is to give it a rear pivot point about here. So a pin can be placed here, another hole here for the pin to actually actuate against, and under the model, if you drill a hole in about here somewhere, you will also give it a pivot point. Those three items there will then provide a small amount of pivot on this bogie from the centre line here to hit the rear, allowing it to guide the locomotive into a corner. The next step from there is to actually provide an actual forward spring, so when it's not just flopping into a corner, it's actually pushing sideways on the locomotive and working just like the real one. Now I've done that on my own locomotive and it works quite effectively. A little hard to show you, but I'll put up a video, in the video, a few photographs. The original part of this got lost on the first video I made. This is the second video I'm making on these models. Unfortunately, all the footage got lost from that first section. So there's a few still shots about to come up. I mounted the bogie with its original factory bracket. However, I drilled some holes at strategic points in the mount, in the actual bogie itself, in the rear section of the bogie, and into the chassis under the boiler section of the model. Now, these gave it a rearward pivot point. Now, that actuation starts to help guide the locomotive into a corner. It's a very rudimentary form, and it only partly does the job. The next part of it is to provide a form of forward actuating spring to come forward from that point to the pivot on the front of the bogie. Now, that was done using a section of phosphor bronze spring, which I then soldered to the original mount across the front there, drilling a hole in the front of the bogie, about in this location, and using the phosphor bronze to act as a spring. So the direction of force into the bogie is then at the front of the leading axle is transferred into the spring back towards the pivot point, and this then actually guides the locomotive into a corner. And it is quite a difference between the standard model and the modified model when it's seen running on a layout. The modified model has several millimeters, up to 5 to 6 millimeters of overhang out on the outside of a corner, as compared to the modified model where it tracks fairly close to the center line of the curve. So it's a modification for a modeler that is actually worth doing. Some trial and error may be needed. I don't think my solution is 100% perfect, but as a basic first attempt, without going outside the bounds of the production model, so using parts from the production model without doing any real serious modifications, it has resulted in the effect required to give side control on the front of the locomotive, and it actually works. Whilst we've got the bogies off the locomotive, the rear delta truck, you should also check the gauging of this one. So bring the gauge in there, and we can see it will not go in the back, so the back-to-backs are under gauge on this wheel is set as well. Easily to remove this one, screw right here, undo, pop the base plate out, and the wheel is then free to be adjusted. Right, with the screw removed, the base plate should come out and the wheel can be removed, and we can then gauge the wheel with the back-to-back gauge. As you can see here, this is quite a bit under this this wheel compared to the gauge, so this will need a good adjustment. Alright, wheel has been adjusted here, slides nicely in and out of the gauge, and we can reassemble it into the delta truck. Sits down there, probably worth giving it a bit of a lube while you're there, because there is absolutely no lubrication on these from the factory. So a little drop of oil on these 2 points here will go a long way to the life of this bogie in the model. And we'll check the gauging on this axle as well. So there we go, it's well under. And the rear one here, flip that over so we can get better access to it, also well under. Not quite as bad, that one, because you could almost get the gauge in, but we'll need to pop them out, screws here, and adjust the gauge on those as well before refitting to the model. The tender of the ARM 38 class is quite nicely detailed. It has a moulded coal load, the toolbox, water hatch detail, very nicely detailed ladder on the rear and steps to the rear of the tender, moulded marker lights, a couple of air hoses, buffers, and we can see the front full plate area there and the coal plate. Brake wheel on the left hand side. Now, something unusual with this tender compared to the majority of ready-to-run models is the wheel arrangement. It has solid bogies. Well, not even bogies, it's just a solid chassis with bogie or the wheels mounted. Very reminiscent of the old Hornby Flying Scotsman. After they went from tender drive to loco drive, they had a fairly solid chassis underneath those tenders with a bit of play in the sides. Now, this actually runs quite well if the wheels are engaged. So what I'll do here, I'll pop out a set of wheels and we'll check the gauging on them. And then we'll move on to the next step of the tender. So pop one of these wheel sets out. And I have a brass wheel gauge here, and we can see this wheel set is well under gauge. It will not fit into the gauge there for the back-to-back. So make a small adjustment there. Oh, a little bit more. And there we see the wheel slide into the gauge. And with all the wheels set to the right gauge, these tenders actually track quite well on the track. So that's something to note. If you're not doing any modifications and going with the Control P tender, check your back-to-back gauge on your tender wheels. Use the NMRA gauge, or like I've done, you can have a proper gauge made up, which is a lot easier to use. It spaces it perfectly for you, that one there. The factory tender comes with a coupler mount on the rear, suitable for an NEM coupler from KD. So the little slots there allow the coupler to push in and sort of retained, I guess, by this undercover plate here. Onto the disassembly of the tender. Now the body is a clip fit, so you grab the sides of it, give it a bit of a twist, and it will pop off. Now this tender under frame has already had the weights removed on it, because we're part way through the build on the other tender. Modifying the tender on the 38 class using the Control P tender kit. So here we see the packaging that comes with the Control P tender kit. This is a 3D printed model, separate bogies, comes with multiple buffers, so you get a choice of buffers. The details are there, you can see it, controlpmodels.com.au. They have a website, you can purchase directly from that website. Great service by the promoter of this. The design is very good. The printing is super crisp and smooth. There are very fine striation lines which are nearly invisible, basically. You can't see them, unlike a lot of 3D printing you get. And for, I think, a production price of about $50, it is well worth getting. Saves a lot of heartache in trying to modify the actual original tender, which we can see has that solid arrangement, giving you proper bogies, nice wheels, comes with all the screws, even comes with the KD coupler and screws to mount the KD coupler. Definitely worth the modification. The biggest advantage of the Control P tender is it actually has proper bogies on these tenders. So these tenders, tip it at that angle, are 3D printed, and they come with everything you need to build the tender. Comes with couplers, bogies with the wheels already fitted to them, screws, detailing parts like buffers, two types of buffers. You get a choice between the tapered Turton buffers or a standard set of straight shanked buffers, or camel I think they call them, which would normally be used for a KD coupler. The Turton buffers were fitted prior to knuckle couplers being fitted to the 38 class tenders when they were hook draw gear. So with the 38 class Control P tender, we have a rotating bogie. A big advantage over the standard factory tender with its solid axle arrangement and no floating tenders. Now it is actually possible to cut these frames off, which are quite nicely detailed, and make a bogie out of them. A couple of the guys in the NMRA groups have done that and used the original base of the tender and the original parts and made bogies out of them. Additional to the Control P tender, something you may like to add is tender pickups. Keeping in mind that the locomotive from the factory only picks up from the 6 driving wheels, adding some extra pickups greatly increases the reliability of the model, especially when you move to DCC. In this case, I've added a section of PC board to the underside of the bogie. The wires come through the chassis a couple of phosphor bronze wipers to the back of the wheel, and that provides very good extra pickup. This locomotive will run around the club layout with no pickup issues whatsoever, even with dead frog points and the like on the layout. The ARM38 comes with the standard style of drawbar, a plate with 2 holes located in it to give a close couple and a long position. Currently this unmodified version here at the front has the close couple position, which gives just enough to go around a corner of a standard sort of point, or probably a 24-inch radius curve. Much more and it will start to bind up on the back of the model, and you may get some derailing issues. So you'd have to go to the longer hole position, which gives quite a large gap between the loco and tender. To overcome this on my own model, I've experimented with a sprung drawbar. Now, I've been doing this on my O-scale models for a long time, and so I thought I'd give it a go on the HO version. So the drawbar uses part of the wiring harness and a pin, and it is actually sprung. So the wiring harness runs through the same section as the pin, and it can open up and then come back, pull out, and it snaps back into position. So a set of rubbing blocks was mounted on the control P tender. You can just see the block in there. Oh, lock the camera. One on the left hand side, one on the right hand side. A little bit of shaping on those so they give a smooth rubbing surface on the back of the locomotive. So with it completely compressed, it sits on both of them. As it goes around a corner, it will pull out, and you can get to quite a tight corner. So that there is well under your 18-inch radius without applying enough pressure that would derail the tender. And you can see it there, well open. Yet you've got that nice close coupled look. Pulls out and snaps back together. You can see that in those videos of this particular locomotive running on the layout, that it looks quite good close coupled. And here's a view from the underside. So we can see those rubbing blocks, and as the locomotive goes around the corner, pressure on those rubbing blocks pulls it away from the locomotive, pulls the spring pressure out, and doesn't create any locking situation. Pull away, comes back. The original pin there is still on this model, and you can see the mounting hole, screw hole here, where the drawbar was mounted. Here you can see the operation of the marker lights on the front of the locomotive. The marker lights and the headlight are LED surface mounts. The actual optics for the marker lights are fibre optic through the brass casting, leading back to a surface mount LED on the inside of the smoke box cover. The headlight LED is mounted inside it with a 0402, I think they call it, surface mount LED. There is a red and a white marker light on this model, and a yellow or warm white headlight. The DCC system used in this model is by ESU Lock Sound, with a sound file I've produced using some of the best parts available in the ESU templates page, and sound recordings I've done myself of 38 class locomotives, and a few other sound recordings of 38 class locomotives provided by people from different periods in time. One of the whistles goes back to the 1950s as a recording. That's on the sound file. Another one is from a 1990s recording of 3830 and one of 3801 prior to its session of operation for overhaul. So there's a little bit of options there for whistles, so you can have 3 or 4 different sounding 38 classes. So summing up, the ARM38 class is a budget model at a recommended retail price of around $300, available from a lot of suppliers at under that, about $285 I've seen it. It is keenly priced, quite a bit cheaper than any other New South Wales or Australian steam locomotive on the market. A few shortcomings of the model are easily fixed by the modeler, and extra detail can be added, or a little bit of paintwork to disguise some of the model's shortcomings, and no one will really know when it's running around at that viewing distance on the layout. Would I buy another one? Definitely yes. It's one of those models that you can get stuck into doing some modifications and not have a real worry, am I damaging that really expensive model? I have several brass models of 38 classes, and would I be going and cutting them up? No, because at the current value of those models, it would be probably devaluing them. So getting a plastic model that you can add detail to and flog around a layout without having to worry whether you really wear it out, it's definitely worth the $285 and a few dollars on extra detail parts and adding a nice sounding decoder to the model. So with that speaker mounted in the front of my model and the other one here, they really bark as they run around the layout. So you've probably heard at the beginning the locomotive running, and I'll run a few more videos at the end here so you can see the models running around the layout. Alright, thank you for watching the presentation.
Oh, you're going down the hill. Did you want that?
That's alright.
Sorry, Corey.
Righto, guys. That was a great clinic there. From Chris, I actually thought I'd change it up a little bit and jump over into the lobby and see what everyone's doing to close this session out. So we're over here at the moment. We've got Darren, Craig, Jordan, Speed, and Gordy. So say hello, guys. You're live on TV.
Where's Jordan?
Well, he's
Hi,
sitting
Rob.
in a car.
There comes Landon.
Okay, so Martin, I believe you've got a bit of an announcement we want to make before we kill this stream and go to dinner.
Well, we've got some breaking news that earlier this morning we had a problem contacting Dave Abeles and we couldn't get him on for his clinic, but we've reinstalled and reset communications and the electrons are now working on their way from Australia to New Jersey. So Dave will be here at 10 a.m. tomorrow morning, and it's a clinic not to be missed, especially if you're into operations, wanting signalling, interlocking, and a whole host of other subjects. So that'll be a very good clinic to attend. So the other two clinics that are after it are being pushed back 1 hour, and we'll run clinics through the lunch break. So there won't be any videos or lunch break. Brad and I are going to work through. We're going to slave through. Hopefully someone will bring us some sustenance out to the relative sheds. But yeah, that's where we are at the moment.
Okay,
So
quickly, Martin, I'm going to interrupt because this is the sort of stuff that the guys that could jump over into this lobby and catch is we've actually currently got a live stream from Jordan over in the States at the moment doing a bit of rail fanning. So look, use this lobby. I'll put the link in the chat in the new stream. Jump over into it, and you never know what you could catch.
Yep.
So
we're going to we're going to restart the stream now. So this will be this stream will be stopping. And if you subscribed on YouTube and hit the little notification bell. You'll get an email telling you of the new link. If not, just keep an eye on the YouTube channel or the Facebook page, and within the next couple of minutes you should see a new link come up.
Perfect, no problems, and we'll be back on the hour with the next show.
See you then.